Continuing with the ABug series of talks from people in the industry back in the day, today we're lucky, very lucky, to have one of the key contributors to the world of networking with Acorn computers. He worked at Acorn and later at SJ Research, and is one of the team who have their names immortalized in the BBC's OS 1.2 ROM code. Today he's with us to tell the story of computers in schools, Econet, his time at Acorn and SJ. Ladies and gentlemen, it is Andrew Gordon.
Well, thanks very much for that. Yes, as Mark said, the story I want to tell today is about Econet, which is tied together with SJ Research, and in the background to all of this is what was going on in schools. Why did schools want an Econet, and how did we come to deliver it to them? I felt that there's a lot of information about what we did. The equipment's still all there, people know how to use it, but people don't know why we did it and how we did it. So that's what I'm hoping to tell you today. And then, because I was originally invited to give a talk on account of being at Acorn in 1981, now I don't think I actually achieved all that much in 1981, and it was my apprenticeship, but I was there at a very interesting time as a fly on the wall, so spliced into this, what is trying to be a coherent story about Econet, a few digressions into what was happening at Acorn in the time when I was there. The world before Econet. I guess a fair number of you are a similar age to me, but so you'll know about this, but those who are younger will, not know what it was like before computers were around. So the story for me begins in 1976 when I was a teenager going to a new school, Felsted School, and my school had a computer. It was an Elliott 803, a 1960s machine that had been donated to the school. It belonged to the maths department, so it took me a fair while before I discovered it was even there. It was a machine with 8K of 32-bit words and a 2 kilohertz instruction time. I could spend all day talking about that machine, but it's off topic for today. And it was British made. We'll come back to that in a minute. So I was fairly lucky to be at a school with a computer. It was a bit random whether schools had computers or not. It was not a matter of being a wealthy school or as such, it was whether there was somebody who wanted it and whether there was somebody local who donated it to you. So we got to know the other schools who had the same type of machine as us, and they were a wide spectrum. And Loughborough Grammar School had one because Brush, who make railway locomotives in Loughborough, had donated theirs. Wanstead High School, which was a comprehensive school in East London, they'd got one from somewhere. Other schools had different types of machines. Andal had a Data General Nova. So it was rare, but not exceptional to have your own machine. And people who didn't have their own machine were still doing a little bit of computing. They would send cards or tapes to somewhere that did have a computer. And all of this was a branch of maths. You didn't do computer literacy in any sense. That wasn't even something that was thought about at that point. Computing was a sort of specialty interest, and you wrote your programs that were sort of mathematically oriented, and you sent them in. If you were lucky, you only had to queue for 10 minutes to get to the machine in front of you. If you were unlucky, you had to put them in the post and get the results back. But it was all that kind of very specialist subject, something most people not involved in, and it was just on the point of beginning to change. There were a few people who who were beginning to realize that computers were going to be an important thing in the world and schools needed to do something about that. So, also joining the school, by coincidence the same year as me, was a teacher called Christopher Dawkins. He really wanted to teach computers, but in 1976, there weren't any jobs for people to teach computers. So he got a job as a chemistry teacher, but he picked this job because the headmaster, he had an understanding with the headmaster that computers were going to become important and that eventually he could move into that role. But in the meantime, he had to teach a full timetable of chemistry to earn his living. He had a rather different approach to how computers should be in schools than this sort of send your mathematical programs in and so on. He thought that people should experience computers in their daily life. So he set about, with the help of pupils, computerizing the school roll, and there was an athletics thing where you could earn awards. So we collected up the athletics results and put them into the machine, and results would appear on notice boards. If you took his chemistry class, you got your test results normalized for mean and standard deviation and so on. So that this was moving more into the exposing people to computers as opposed to teaching the mathematics and programming as such, apart from those of us who were into it, who of course were much more into it and were now writing real programs as opposed to solving simultaneous equations by post. So we did that with our 803. We got a few more bits and pieces, like that machine you can see top right gave us upper and lowercase letters instead of the all uppercase we had before. We got a second 803. So, I think British Steel were scrapping theirs, so we managed to pick that up. Then he had a bright idea. We had no budget for anything, but there was a maintenance contract on the 803, and if the pupils could take over the maintenance, then there would be a budget for toys. So we did that, and we could buy things like a NASCOM 1, and then we bought a NASCOM 2. We interfaced those to the 803. We bought a CompuKit UK 101. We bought a ZX80 that was completely useless. And we bought an Atom. We built an Atom from a kit. We didn't follow the advice in one of the computer magazines at the time that you should poke a pin into the IC sockets to make it easier to get the chips in. But even so, under heavy pounding, the chips on the Atom did tend to fall out. But the ones we got later, the machine assembly made, were more reliable in that regard. So what was going on in other schools at that time? There was an organization called Muse, which at the time stood for Mini Computer Users in Secondary Education. Luckily, later on, they quietly changed the name to Microcomputer Users in Secondary Education, but it was minis at that point because micros were a new thing. One of the big movers in Muse was John Cole, who is important to this story because he was both on the panel that the BBC organised to pick who was going to make the BBC Micro, and after that panel had awarded the job to Acorn, John joined Acorn and wrote the BBC User Guide. The other thing that Muse did was organising an educational software library. Remember, this is the time before packaged software had really got going, so what we now call open source was really the norm. People were swapping bits of software around to do various things, and you would go to the Muse conference and you would see what other people were doing. And so the hot machine that everybody wanted in about 1978 was the SWTPC 6800, which you see bottom right. Although the research machine's 380Z was British made and new and there were some people who were keen on that. Apples and pets appeared around that time. There was all sorts of other stuff. Everybody bought, everybody had tiny budgets. They bought something that they could get hold of, and nothing was compatible with anything. And we all looked at what other people were doing, were envious of their big disk drives if they got a big disk drive, or envious of their graphics if they got a graphics machine rather than one that took a dumb terminal. All of this was sort of 1 or 2 machines per school, nothing suitable for per pupil use. So at Felsted, we carried on with the bits and pieces we were doing. We got an 8-inch floppy drive, interfaced that to our NASCOM, transferred our big databases off the 803 onto micros, and we started dreaming of site-wide facilities. Chris bid in a bankruptcy auction for some dumb terminals. He didn't win them, but there was a plan to put some dumb terminals around the place to a central machine. And then reading in the press, we began to realize micros on networks was perhaps more reasonable than dumb terminals to a central machine. Then an interesting thing happened. It was particularly interesting because I've kept the paperwork from then. The DTI organised a competition, write an essay and win a computer for your school. So of course I wrote an essay, bit of a cheat really, because although it was all my own work, I'd had a lot of briefing from Chris Dawkins about what we were going to do with computers, and therefore it was probably more his ideas than mine, but it was within the rules. So as I say, I've still got that essay in my filing cabinet, and it said that we wanted a network. It was probably going to be a Cambridge ring, because that was what the magazines were full of at the time. It was going to have view and remote. It was going to have teletext and Prestel servers. It was going to have file and print servers and all this sort of stuff. So that's what we were dreaming of. And eventually the 380Z turned up. Still got no budget, but we managed to sneak an extra member of staff on the government YTS scheme. So he was paid a pittance and was officially working for the Clerk of Works and the Works Department, which came in handy, because if a teacher or a pupil had been digging up the lawn to put a network cable in, that would have attracted unwelcome attention. But somebody who worked for the Clerk of Works could reasonably be seen wandering around with a spade, so that was quite handy. And as a slight bribe for Stephen, we were scrapping the 803 by this stage, and so he got a bonus of any gold out of the edge connectors, which there were an awful lot of edge connectors in the 803, and in those days they had quite a lot of gold on them. So that got us someone who was available to write software and lay network cables, and we had no idea what sort of network we were going to have. But we found some nice cheap cable in the RS catalogue, and we started laying some of that, or Stephen started laying some of that around the place. And we started doing experiments with the 380Z at one end of a piece of wire and the NASCOM at the other end. So all in all, our plan for world domination was going really quite nicely, apart from the fact that we really needed a network and we didn't know where we were going to get one from. And then Econet was launched. I believe it was announced at the Compex show in Olympia in November, but the real launch was an event in a hotel off Russell Square in London on 8th of December 1980. So that to me is when Econet begins. Somehow we'd wangled an invitation to that, and it was quite amazing. We went there and Acorn was showing off all those things that I'd written as pie in the sky wishes in my little essay. They had a file server, they had a print server, they had view, and they had remote, and they were using the same cheap 4-core cable as we were. So we were really quite amazed at this. The Acorn people were also quite amazed when we told them that we'd actually got several hundreds of meters of cable laid between buildings, just waiting for a network to be run over them. So at the demo, they were showing a system 3 and a bunch of atoms, and we could play with them at the launch, and it all worked. Their big advertising message was £50 a station. But it was also clear from the advertising material that it was a proper layered software. It was a real network with file serving over the top of it. It wasn't what some other things were, a sort of, a kludge to do disk sharing. So in detail of what you had, there was a system 3 as the file server. There was an Atom acting as a print server. The file server at that stage was fairly crude. It was equivalent to what we called a level 1 later on. So it was using the Acorn DOS and just serving out the existing disk structure, no directories or whatever. The network at that stage had only 8-bit addressing, so the idea of bridges wasn't yet in the design. The clocks and terminators were on the Atom interface boards, which was a royal pain in the neck, we found, when we were moving them around our big network of cables, and it was always in the wrong place. The software had version 1 of what we called the primitives, the lowest level of the network software, which had a 4-way handshake. First packet to say, I've got something for you, an acknowledgement to say, yes, I want it, the data packet, and a confirmation at the end. The hardware had collision detect. Some people say it's just RS422. Well, no, it's not just RS422. It's got the collision detect, as I say, and it's got a high fan out, which normal RS422 doesn't give you. I've seen lots of other reports saying that it was designed by Andy Hopper, which never quite sat right with me, because later on, Andy Hopper never took much interest in the Econet low-level stuff. I've spoken to Lawrence Hardwick, who I did remember being interested in it at that time, and the answer is apparently that Andy Hopper had sketched a design which had some of the features of what we now had, but Lawrence Hardwick had been given the task of actually doing the circuit design we see today with the high fan out and with the well, he tells me Andy Hopper's had a current based collision detect, and his version had a voltage based collision detect. So anyways, that's the story behind the hardware. The software was done by Paul Bond, who was a consultant at Top Express who did lots of work from Acorn, as we'll see later on. So that's what was there in December 1980. Acorn were supporting trials in schools. They gave us the system 3 and a couple more atoms to go with the atom we'd already got. They gave a set to Long Road College in Cambridge. So they were obviously clear that schools was going to be something they used it for. Although I've looked up magazines from the time, and Acorn's press advertising sort of put all in one advert. If you want networking, we can do it. You could either have Econet, which was cheap, or Cambridge Ring, that was going to be fast. Later on, the Cambridge Ring stuff became the separate company, Orbis. But at that time, Acorn was sort of feeling out how they were going to market this stuff. It later became clear that Econet and Cambridge Ring were radically different markets, but it wasn't quite clear at the time. So we went back to school with our pile of atoms and we started playing with them. For our speech day, open day, we managed to have a demo with 3 machines spread out across 500 meters, and we wrote a little network messaging app where you could type short messages and it would appear on the screens of the other 2 machines in a sort of chat style. And we started making Econet interfaces for anything that moved. We first off had a Atom board kludged on the side of the NASCOM 1, which let us run a sort of network monitor thing so that we could see how it all worked. But it became clear the right way to do networking in Z80 machines was to use the Z80 SIO chip, which was the Z80 family equivalent of the 6800, 6502 family 6854 chip that Acorn were using. So we were having lots of fun doing that. And like everyone else, or like all the other schools, we were starting to see that finally we were going to have some budget and we're going to spend it. Obviously, we were thinking more about spending it, but other people had to think about where it was going to come from. But there was a general feeling around everywhere that micros in schools was about to be a thing. And then the BBC Micro was announced, and that became clear that that was where the money that was being rounded up was going to have to be spent. BBC Micro wasn't quite available yet, so that year Felsted blew nearly all of their budget on a 20 megabyte 8-inch hard drive. So summer of 81, BBC is still not out yet, but Econet was moving along. Version 2 of the primitive software. This was a cunning wheeze by Paul Bond. One of the snags with the 6854 chip that Acorn were using was it didn't have any address filtering, so every station on the network got interrupted for every packet. Then looked at the station number and decided it wasn't interested and went back to sleep. But if you could reduce it from 4 unwanted interrupts per transmission down to 2, that would be a good thing, which you achieved by, instead of the acknowledged packets that you had previously, it used the difference between an active idle and a idle to do the acknowledge, which was a very cunning scheme, but unfortunately it relied on the collision detect hardware working 100%, which it didn't. So we had a lot of trouble with that on our big network. It worked okay in a small lab network, but once we got it out on hundreds of meters of cable, it just didn't work. Also around this time, the what later became called the level 2 file server, the proper Econet file server is how we thought of it at the time, which had hierarchical directories, it had passwords, *IAM, and all that good stuff. It had been written for Acorn by Carl Deller, who was a PhD student in the computer lab, and Joe Dunn, who was Acorn staff. Joe tells me that Carl was the main architect and wrote the sort of core file engine of it, and Joe did the Econet, the client and the server end communication stuff. But however it was done, those two did a cracking job on the file server. It was written in about 9 months from scratch, no previous real structure to put it in, and it was a cracking piece of work. It really set up Econet for the future. We got given this software. We had to build up a real-time clock card for it because the file server timestamped all its files. So that circuit diagram you see in the corner there is the circuit for the System 3 real-time clock card. Later on, Acorn gave up on that and made you type the clock in, the time of day in on your BBC Micro when you started up the file server. But that first version expected a hardware real-time clock. And around this time, we were dealing mainly with Lawrence Hardwick and Paul Bond, who were trying to debug the hardware and the lower layers software, and working on this version 2, which unfortunately didn't quite work. My summer holidays in 1981, we took a trip to Limerick for the Irish equivalent of Muse. So big gathering of teachers and Limerick, we took Atoms and the Acorn file server, and we bumped into the Irish Acorn dealer who had a network of Atoms with version 1 Econet. So I mentioned that. So although it all seems to have disappeared, I can't find anyone who's got any version 1 or no documentation of what it exactly did, but I believe that version 1 was actually sold to people. It soon got swept away with version 3, but it did actually get out in the wild. Anyway, this Irish dealer was very interested to look at the version 2 stuff that had sneaked out of Acorn's lab onto our machines. We also borrowed a new brain for that trip, which was quite entertaining. I didn't realize at the time that that was would have been the BBC Micro. Next story I tell just as show how laid back things were at Acorn at the time. The day I stole a carload of Atoms. One day in that summer, I got a message from Chris Dawkins, which I understood to be that he'd arranged with Chris Curry that we could borrow a pile of Atoms with Econet to take to the Muse conference and do a demo. So I toddled up to Cambridge. At that time, I'd met a fair number of the people at 4A Market Hill, but Chris and Herman and all the marketing and admin people had moved to a different office on Bridge Street. So I wandered in there and said, Chris Curry's promised us a load of Atoms, how about it? And they said, oh, well, Chris isn't here, hasn't told anyone about that. Well, that's not surprising. Tell you what, if you go over to French's Mill, they've got some Atoms there, they'll sort you out. So I went over to French's Mill and said what I wanted and loaded up my car with Atoms, and away I went. A little while later, I discovered that I'd misunderstood the message, and it wasn't that it had already been arranged to borrow these Atoms, it was that we were going to arrange to borrow these Atoms. And so I just walked up at Acorn and told this story and walked off with all these Atoms with actual, nobody I spoke to had ever met me before. They just gave me some Atoms. Luckily I was honest and I took them back later on, but that was the way things were at those days. As I said, I'd been up at 4A Market Hill doing a few things. Chris Oswald I met at that point. He'll pop up in this story a couple of times later down the line. I believe he was doing something with Prestel, which I believe was AtomTel, Prestel on the Acorn Atom. I'm really not quite sure what I was supposed to be doing. I rather suspect that by the time we'd actually got all the hardware sorted out, I never had time to do any of it. If I could image those two floppies you see on the slide, it might give me some clues. The other thing I found in my filing cabinets is all the paperwork from what you see on the left corner there. Remember, this was 1981. BT had only just been split off from the post office, and all telephones belonged to BT, and you couldn't plug your own telephones in. But now people were wanting to connect micros to the phone network. So we applied for experimental permission to connect an Acorn System 3 to the telephone network and get a socket installed in my parents' house and at Felsted School so that we could do this work. And that document is quite interesting reading because in those days, they expected to approve the entire machine. So as well as asking you what sort of computer it was, they wanted to know what was the voltage of the high voltage inside the screen monitor. They wanted to know, all the interfaces it had and so on. So our first draft of this, of course, this System 3 has Econet. So, you've got the whole building to be approved, but there's scrawled on notes from Lawrence Hardwick saying, don't put that, you'll never get the approval. Anyway, somehow or other we did get the approval, and I did get the Prestel socket and my System 3 connected to the telephone network. I have a rather suspicion that I didn't actually do any work on it that summer. So a quick aside on Prestel, which although it's not part of the story we're really telling here, it does keep popping up. For those of you that don't remember it, Prestel was Europe's internet in many ways, a dial-up information service with an X25 network, which you could say was Europe's equivalent of TCP/IP. It did page layout, it had forms, it had email, and it was about to be a big thing around that time. France Telecom were rolling out large quantities of their equivalent Minitel. Schools thought that Prestel might be important as an information source. Acorn were in a good position to do Prestel because they built their graphics around the SAA 5050, both on the System 3 and then later on the Mode 7 display on the BBC, which was the display you needed for Prestel. And of course, Prestel was a requirement of the BBC contract. So plainly, Acorn were doing Prestel on their machines. However, Prestel editing terminals were very expensive at that time, and you could make one out of a System 3 and a bit of software. So there was an obvious market there to make one, and at the end of the summer, it was agreed that when I'd finished school, I would go to Acorn and have a job and make one of those. There's a further aside to this aside. Note that Prestel on the X25 network were built on GC 4000 computers. GC Computers was the successor of Elliott Automation, who built our 803 computer. And one of the big people at GC Computers was John Horton, who became Acorn software manager and later Acorn R&D director. So there's interconnections between people all over this stuff. Right, so as I said, in December 81, I had a job at Acorn to write a Prestel editing terminal. So I turned up there, and it was an interesting place to work. One of the key things to say in hindsight, hardly anybody on the technical side actually worked for Acorn. Or in fact, if you're pedantic, nobody worked for Acorn. Those of us who were on the payroll worked for Cambridge Processor Unit, which was the company that Chris and Herman had set up to do consultancy jobs like the one-armed bandits that they got as their first project. Indeed, there were still some one-armed bandits hanging around in the corner of French's Mill when I went there. But there weren't that many of us even on the CPU payroll. Most of the people working on the BBC project were outsiders of one sort or another. They were students who'd been found at the computer lab, gap year students like me. They were PhD students like the guy who wrote the file server, or they were contractors. And a lot of the contractors were trying to do exactly the same as Acorn had done. Because Acorn had started off doing the fruit machines and contracting and gradually expanded into products. So a lot of the people working at Acorn were working at Acorn to earn a bit of money and then go off and start their own company to make their own products. The other thing I noticed with hindsight is Acorn had just moved into Fulbourn Road when I went there, which is a big commitment for them to have made. It was they'd spent a lot of money on converting the office. It was nicely fitted out. We all had new desks and filing cabinets and stuff, which must have come just at the point where their cash flow was in dire straits because the BBC wasn't yet out in volume. So looking back on this now, they'd made the big investment when they needed to. And Acorn was just starting at this point to become a more conventional company. So this business of nobody actually worked for the company was changing. The staff was being built up. So more things were in-house. And there was a new tier of management introduced with people like John Horton and coming in. So again, it was becoming a real company rather than the seat of the pants startup organisation. But it was a very interesting time to be there in that sort of transition. So, need to tell you what I was actually officially working on there. You might think I was about to tell you all about Prestel, but no, I turned up on day one and they said, oh, well, forget about Prestel. Much more urgent is teletext on the BBC Micro because we've got to deliver that to the BBC. So I never did finish the Prestel editing terminal. In fact, nobody at Acorn did. Soft Machinery went off and did one. So I was doing the teletext on the BBC Micro, which was a piece of hardware where the analog hardware had come from the BBC Designs department, and Mel Pullen had pulled together the rest of the design. It could capture the raw data off a frame of teletext, 16 TV lines, and then you got 20 milliseconds to whip it out of there and process it. It was absolutely ideal if you wanted to write a network teletext server. Unfortunately, by the time people actually did start writing teletext servers in earnest, this generation of the teletext adapter had gone out of date, and much less the so-called advanced teletext adapter, which was actually much less advanced, it was just cheaper, was much less suitable for writing the teletext server, because the big thing with this hardware, you had the raw data, you could download multiple pages in parallel. Well, that's looking to the future. So I took over from contractor Mel Pullen, doing the basic software to make it work and fit into the BBC operating system. Chris Oswald from previous stuff about Prestel, he was doing telesoftware. Telesoftware was a hugely complicated and highly political business for some reason that didn't make sense to me then, and certainly doesn't make sense to me now. It was declared that telesoftware had to be both machine readable and human readable. So you had to have your telesoftware sitting on a CFAX page that if you looked at it, it looked like a nicely laid out program. But if you downloaded it, it would be a nice binary program that you could load with a load statement and run it. So there's vast amounts of documentation effort and meetings with the BBC spent on that, which was mostly Chris Oswald doing that side of it. And a bit later on, Kim Spence-Jones got involved in getting the hardware actually into production, which is the job he'd been doing on the BBC project. Whilst people like Steve Fober were handling the sort of major things, Kim was doing the job of tidying up all the rest of the machine to actually get it manufacturable in the factories. So he took on doing that job for the teletext server, which proved harder than you might expect. Because this design from the BBC Designs department was fine if you had a BBC Designs department technician to set it up for you, because we'd spent days fiddling with this prototype and it was sort of working, but the quality was rubbish. We went down to the BBC and their technicians waved his hands over it and twiddled all the twiddle pots, and suddenly it was perfect. But it took a fair bit of work to actually make it manufacturable in a factory as opposed to BBC magic. And the other thing I would say out of that was my culture shock at going to meetings at the BBC. I particularly remember one meeting at Kingswood Warren, because Acorn was a fairly laid-back sort of place, but we went down to that meeting and there were 4 of us there. So there was Mel Pullen, who had been doing all the project up to that point. He knew everything about what was going on, but he was fairly scruffily dressed and BBC didn't want to talk to him. There was Herman, of course, was the managing director, so you'd think he would be quite important, and he was smartly dressed, but smart casual. He wasn't wearing a tie, so he wasn't that much paid attention to. I was wearing a jacket and tie, so I was sort of fairly okay. And then Kim, who at that point wasn't really on the project at all and just come along to see what was going on, he was wearing a suit, and the BBC really looked up to him. So that, as I say, was a culture shock for me. I remember that I don't remember any of the technical stuff from that meeting, but I remember that aspect of it. So what was it like at Acorn? There's a bunch of random anecdotes here which don't really relate to anything else. Picture on the right hand side is an answer to a question in one of these previous talks, which said, how did you do source control in the 1980s? Well, when I first arrived at Acorn, there was a bit of a floppy shortage and people weren't backing things up, and this was thought to be a bad idea. So shortly afterwards, we were each issued with 3 boxes of floppies, box A, B, and C, and we were supposed to rotate those and keep versions of our software so that, yeah, we kept things under control. The blue notebook there is a bit later. That's the SJ file server changes and bugs log. But again, that was the sort of thing you did. You kept things in notebooks, and yeah, there were no tools for this. What else there? Yeah, we all went out to the pub for lunch. The Econet team went to the Checkers. I don't know why. It was a miserable pub, and it's now been knocked down and replaced by a street of houses called Checkers Close. The hardware people and some of us went to the Red Lion. Management went to the Robin Hood. And some people drank Guinness, and at the time Guinness were running a sort of scratch card promotion. And for some reason that escapes me, you could increase your chances of winning by analysing previous failing. You scratch off all the boxes on the tickets that you lost and built up a database that could give you a better probability of scratching the right box on the next one you had. So someone wrote a program on the BBC Micro, and after we went to the pub, collected up all the tickets and put them in, and then next week, yeah, you'd have a better chance of winning. Shortly after I arrived there, a memo went round saying everyone shall arrive in the office by 9 o'clock. Well, we gave it a try for about a week. I think I got there about 9:05 on the day after the memo. We gradually drifted back to coming in when we woke up and staying late into the night. I think basically this was the first time that Acorn's technical department and the sales and marketing people who had to come in on time to answer the phone were all in the same building, and it rather shocked them that we didn't work 9 to 5 hours. So software and hardware were upstairs in the office, and cup of tea in the afternoon, you'd go and make a round for everybody and carry it upstairs. The bottom half of an Atom case is an excellent tea tray. BBC one's useless. It's full of holes and you spill the tea down your trousers. So use an Atom if you need to carry a few cups of tea. We all had System 3s as our development machines, which had their RAM in the form of 8K static RAM cards. If you went away for a couple of days, you needed to have a good look when you got back, because it was quite likely the RAM size of your machine would have gone down a bit. There was the day we spent throwing BBCs down the stairs. At this point, Acorn were getting a lot of complaints coming back from customers that their BBCs were damaged on arrival. And we couldn't understand this, as we put a BBC in its packaging and we jumped up and down on it and we threw it down the stairs, and we couldn't cause the damage that the post office were doing, where the 3 LEDs got pushed up through the case. Anyway, eventually it was solved by putting a bit of foam rubber in the packaging to protect the keyboard, but that was just one of the jobs that, that sort of floated by. Yeah, an Econet one. We used Econet for real purposes. In particular, the big printer, which used to live in the gents' lavatory at 4A Market Hill, was now on the landing at the end. And if anyone wanted to print anything, they needed to print over Econet. But the Econet guys, of course, were testing new versions of Econet and jammed it up. So there was a machine that was sitting there the whole time, checking for the network being down. And to begin with, it played Yellow Submarine when the network went down. And then the voice ROMs for the BBC turned up. This was before the Kenneth Kendall ROM had been made, so we just had the TI Technical Vocabulary ROM, which had a rather curious selection of words, but it did include the words, "Get off the line, you tool." So the BBC now played that if anybody jammed up the network. Herman, a charismatic leader, I wrote. Yeah, I mean, Herman didn't have time to spend much time in day-to-day R&D operations, but we all knew we worked for him, and we all, yeah. He was somebody you wanted to work for. Everybody told Herman stories. To give you one example, just after I arrived, he was zipping off to New Zealand to get married because his wife was a New Zealander, and he had to rush down to London to the Austrian embassy to get himself a passport. And it was said that he'd never had a passport, that he'd always managed to travel to and fro in Austria and the UK, just bluffing his way through customs on a driving license. I have no idea whether that was true, but the point is we believed it was true. We believed he had the charisma to get through British immigration with just a driving license without a passport. And there were lots of other stories told like that. He was the sort of guy that you didn't do what he did, but you liked the fact you had a leader who did those things. Another thing I remember from that summer was Brian Jones wire wrapping lots of different versions of the Electron. It went through, they did one version which was not good enough, and they did another version that was too expensive. And the thing you can't read in the bottom left corner of the slide is a chart from the drawing office showing all the different versions of DRAM chips that were available at the time and what their timing parameters were. Another but slightly relevant diversion. Torch was around at this point. They were building a business-oriented machine using a BBC motherboard and a Z80. Originally, that was a friendly joint venture with Acorn. Suddenly, the word went round that we're not allowed to talk to them, and Acorn and Torch had heavily fallen out. I think my next line on the slide is a conspiracy theory beyond actual truth, but anyway, another of the important guys to my story, John Cox, who'd been at Oundle, the people of John Cole. He'd previously been working at Torch, but instead of going back to Torch, he came to Acorn in 1982, and he did the DFS and then some work on the Z80 second processor. If things had been more friendly with Torch, he might have gone there and the story would have turned out differently. Yeah, because of this, Torch's Z80 didn't use the tube chip. They used the tube connector, but they did their own thing. However, they did have a thing called TorchNet that used standard Econet primitives at the bottom layer and their own file serving stuff on top. And later on, they did a 68,000 machine with Unix, and a spin-out company, IXI, then provided X-desktop software for the Acorn R140. So eventually, things came back. Coming back to the Econet story, another little anecdote from my time at early 82 in Acorn. I wasn't officially working on Econet, but I was still interested in it. And this new office at Fulbourn Road had lots of new network wiring put in by electricians who can't do network wiring, so it didn't work. So in the evenings, myself and Brian Robertson, who'd just come on board to write the version 3 Econet software, we went around debugging this wiring and getting it going. And there were several separate networks, and all the short ones were soon working nicely, but there was a big long network around the building, and atoms just didn't work properly on it. And eventually we thought we got all the electricians' bodges out, and it still didn't work. And finally we discovered what the real problem was that had been dogging us all this time with the non-working collision detect: the resistors. Unfortunately, I haven't got an atom, so I've given you a picture of the BBC board there, but it's the same problem arises. You've got some very high impedance signals on one set of resistors, next door some low impedance signals, and if you bend those resistors so that they're close together, they will couple across and cause interference. If you bend them slightly apart, they won't. So we took our atoms and we artfully bent our resistors and everything sprang into life. We were really quite pleased with that. We zoomed off into town and had a slap up dinner at the Italian place in Market Hill. Having discovered that, the issue 4 of the BBC main circuit board was just about to be closed. So the next morning we were in the drawing office and laying out the Econet circuit quite differently to avoid this problem. In the end, we were able to change component values, and the actual original BBC circuit did work well enough to be used, but we went belt and braces on the issue 4. Issue 4 threw out the clock and terminators, which we already knew was a bad idea to have it on the stations, and it was much better to have separate clocks and terminators. It was easy to decide to throw that out to make space and then lay all the resistors flat, which solved that problem. So if you wondered why issue 3 and issue 4 of the BBC circuit are quite different, that's the reason. So Econet on BBC has appeared in the summer of '82. So NFS3 around Easter '82, it was working. No BBCs had officially been built yet, so all official BBCs were issue 4 or later, but you could fit the parts to an issue 3 board and get it going. The full release happened in the summer with NFS 3.34. We'd sneaked a few out to Felsted a bit before that. The proper file server at that time was on a system 3 or a system 5. I don't think many system 5s were made, but they were a 2 megahertz version of the system 3 basically. And so that file server was the proper file server, and then there was a thing that was at the time called the Model B file server, was in BASIC and was again this very limited file server for cheapskates who couldn't afford a proper one. Later on it was called the Level 1, but not at that time. Felsted meantime, they'd ordered 24 BBCs and the first couple had turned up. They were desperate. I found some letters where they were desperately pleading for some Econet interfaces. In the meantime, they got a room that was wired up for Econet, but instead they'd plugged the cassette leads in and were doing parallel loading of multiple machines from a single cassette recorder, which apparently worked, but was not fun. So sometime I managed to sneak out some Econet interfaces, and we had a conference there, a whole bunch of teachers invited to be indoctrinated about Econet. Joe Dunn was invited down from Acorn, which was a bit of an ambush for Joe really, because by the time he got to speak, Chris Dawkins had already presented everything about Econet that he was going to tell them, and so poor Joe was just fielding a whole bunch of teachers who were saying, where are our BBC micros and why are the few that have turned up damaged, and when are we going to get the Econet? None of which he was really in a position to do anything about. Other things going on at Felsted at that point, we were getting our Z80 machines properly working on version 3 Econet. Us meaning Stephen Lawrence, who was now a student but going back to Felsted on weekends and holidays, and myself on weekends. And we built Econet interfaces to anything that moved. Someone lent us an Apple II clone, so we put an Econet interface in that, of which the hardware probably worked. But since we weren't really into Apples, it was sent to somewhere in Ireland. And so far as I know, they never finished it. So that takes me to the end of my time at Acorn at the end of '82. And the beginning of SJ research. This was a company called Philip Spence Jones and Associates Limited. So in just the same way as Acorn had Cambridge Processor Unit Limited, which was their consulting company before they got going with products, here was Kim's company that he was consulting for Acorn, among other people, to earn money to set up a product company. Everybody was doing that at the time. There was no venture capital around, so if you wanted to start a company making micros or whatever, you earned yourself some money, and then you set up the company on the side and you gave it a different brand name. So SJ Research was the brand name for the products from the company that already existed. It was briefly PSJ Research. If you find a very early 380Z board, you'll find that it's got a P possibly scratched off. But basically, the company Kim had set up with his friend David Phillip. David was in London, we were in Cambridge, and we were doing different products. So it rapidly became clear that this was two companies, not one company. So we amicably separated, and David Phillip took the industrial control products that they'd been playing with before, and Kim set up with the products that he had in mind. So the products that SJ Research were doing were various things in home control. There was a thing called the R2 you see on the right, which had 2 relays in it. We were highly tempted to make a product with 2 diodes in it so we could have an R2 and a D2, but we never did. There was going to be a much more sophisticated power controller for controlling lighting, and Paul Bond was lined up to do the software on that. It was again, Acorn were now staffing up and laying off their various consultants. And there was the control ROM, which was software to make it easier on a BBC Micro to do control things, which was written by Peter Miller, who wrote the sound subsystem on the BBC operating system. So again, it was Kim's company, but all these other consultants who'd been on the BBC and now laid off by Acorn were doing their own thing. So none of that says Econet. There was this 380Z Econet interface we built at Felsted. There was an obvious market for it because lots of schools had 380Zs and were now buying BBCs and wanted to connect them. In particular, there was a sort of timing issue here that 380Z was available before the BBC Micro, and both of them were on the DTI Micros in Schools funding. And if you were still in the mindset of computers are for a corner of the maths department and you just need one machine that's going to be shared, then buying a 380Z was a very obvious thing to do. And then if you move on a little bit and you think, right, we now want classroom sets of machines, the 380Z was a stupid idea because far too expensive. BBC is much better, but you've now got your one 380Z you bought last year. Why don't you use that on a network with the BBCs? So we developed this thing at Felsted School with Acorn encouragement. We'd always thought that Acorn were going to take it on as an Acorn product, but when it came to it, Acorn didn't want it, which was fair enough. They've got much bigger volume products to do, and it would have been a side, waste of management effort, which they hadn't got. So this was lying around, and Kim agreed that SJ Research would take it on. So what the product was, it was the interface to Econet. We had a client mode. So under the CPM operating system on the Z80, you could access an Econet file server. Over Christmas 82, 83, I knocked up a crude file server on top of the CPM disk structure, in the style that we now call level 1. Stephen Lawrence, who'd written the Econet software, was now a student reading music. John Cox, who'd done the BBC DFS and some Z80 processor work, was also a student, and he'd got lots of CPM experience, and I was doing the file servers. So we advertised the first product in early 83 and started developing that. Later on, we put the same software onto the Z80 processor. Again, Acorn didn't want it, and we released a version as freeware, though whether anyone ever used it, I've no idea. So again, that was all going nicely in early '83 when the call came from Acorn. If you know the movie, the Blues Brothers, and the scene at the beginning where they're putting the band back together, it was a bit like that. Paul Bond had been tasked by Acorn with shaking out the Electron design, making sure that it was actually right, particularly that the operating system was right and was going to have all the interfaces for future expansion correct. There's no way did they want to do an OS 0.1 again on the Electron. The Electron OS had to be the Electron OS and got right first time. So I was a student working in the engineering department, and I got a phone call, which you didn't get phone calls in the engineering department if you were an undergraduate. So God knows what tale he'd spun to get there. You know, the staff sort of looked at me and said, "Are you okay? Family member ill?" Something like that. And I sort of had to not tell them the truth, that I'd just been approached for a moonlighting job that was going to take me away from my proper work for the next month. Anyway, Paul had obviously rung up everyone he could think of, and we assembled a team, and Top Express had an empty office above the Italian restaurant on Magdalen Street, where we had a bunch of production intent Electron prototypes, and we set out to test them. So SJ, meaning Kim Spence Jones and Tim Whitaker, built a huge interface. I mean, in my mind, it's really huge because I can see in my memory the twice life size PCB layout. It was in those days you did PCBA layout with tapes on transparent film at double life size, and then reduced it 50% to make the actual board. But even real size, it was bigger than the BBC Micro. Partly because it had got a lot on it, and partly for speed of layout. It was just, you know, plonked down to get everything on there quickly. But it had all the interfaces that would ever be wanted on an Electron, you know, printers and disks and Econets and things, so that we could test that everything was actually possible with the Electron before it went to production. So we did that, and a lot of time was spent writing test cases, and we found a huge lot of bugs, most of which already existed in the BBC MOS and nobody had noticed. But so we fixed most of them and decided to not fix a few for compatibility reasons. And my main contribution to this is I finally caught a ULA problem. There was a problem we'd been experiencing that sometimes when you wrote a file to cassette tape, it was corrupt. Now, cassette tapes were never 100% reliable, so maybe this was just dodgy tapes. On the other hand, it seemed to happen a bit more often than it ought to. And Acorn had just bought their first digital storage scope that summer, which was, I'd always thought digital storage scopes were a fun tool, so I got hold of that. And one morning I finally caught the cassette interface writing a improper waveform onto the tape. And so we proved that it was a ULA problem, and that ULA problem got fixed. So that was all happening April, beginning of May in '83. And we all know the story that's told that the Electron ULA was late, and they had no Electrons in the shops for Christmas that year. And that led to Acorn's downfall. The story we had was slightly different. The story put around among technical people was that there were loads of Electrons made before Christmas that year, but they were all in the Far East, and nobody had booked any air freight space to bring them to the UK, and all the flights were fully booked. So, you know, and obviously the ULA was late, and that was the major contribution to the problems. But maybe if somebody had booked some air freight space, then the problems could have been less. But you never know. But that was the story we had. Right. So I've now been talking for an hour or so, and we're ready for any questions you might have.
Great, thanks, Andrew. It's been very interesting so far, and lots of comments about how interesting it is and how useful and people are finding it. Timo came in with a question about the Z80 SIO. Is that interesting about the Z80 SIO? Did you develop it yourself, and do you still have the source?
The Econet for the Z80 SIO, you mean?
SIO,
yeah. That I probably still have the source. I have in my attic an MDFS that I saved at the end of SJ, which probably has all the source on it. I also have a load of floppies. I haven't dared power up that hard drive or put those floppies in a drive to try and read them, because I want to do that very carefully to maximize the chance of catching it. So if that hard drive or a tape or one of my floppies is there, then I have the source. If not, then it's been lost. Yeah, so that was the actual low-level Econet was not me. That was Stephen Lawrence. He hasn't got it. I've spoken to him last week in preparation for this, but maybe I have.
Then the obvious follow-up is does Stephen Lawrence have any bits and pieces still left over from those days?
I don't think he does, unfortunately. When SJ finished, which we'll come to right at the end of the talk, I was living around the corner, so I went in there at the end and I got some stuff, and some other people got some stuff. But by that time, Stephen had returned to his music career, so he wasn't there at the death, as it were. That there's various bits of, there's various people I know have bits of kit, but the software source is more tricky to lay hands on. As I say, I might have it.
Okay, and we're having some offline discussions about that as well, and helping you with the preservation project to see if we can assist in some various retrieval activities, etc. So before we get a tirade of questions on that, we'll just sort of say openly what's going on there in the background. Dominic as well came up, obviously interesting talk. What were the problems with the collision detect, and how did you work around them? And I suppose this is obviously until the issue with the crosstalk between the resistors was identified. So, what were the actual, how did the problems manifest themselves, and how did you work around until you actually discovered what the issue was?
Ultimately, the version 3 protocol went back to the 4-way handshake. So this cunning idea to save on interrupting every machine on the network by going to the 2-way handshake went in the bin, which is a shame, really, because it could probably have been made to work. But on the other hand, nobody seemed to notice the effect of these interrupts, and the collision detect, once it was fixed, was 99%, but it wasn't 100%. So maybe it was a good outcome at the end of the day. Was the problem that was presenting there was the collision detect is telling you whether you've got valid data on the line or not, and so the 2-way handshake scheme used the difference between an idle line with valid data, i.e. being deliberately driven to an idle state, as opposed to floating to an idle state, which would look like a collision. So that required the collision detect to be right, and if you had the crosstalk, you could either get, I can't honestly remember which way around it was, but you had the case of the line is genuinely idle and not being driven, but a bit of noise makes the collision detect circuit think that actually is valid data after all. And it would also have stopped its ability to detect collisions accurately, but that was actually not critical, as we'll mention that in part 2. But yeah, that was the outcome of that. We went back to the 4-way handshake.
And you mentioned about the real-time clock on the system. etc. You mentioned that Acorn gave up on it, although it was incorporated in the dongle. Do you know why that Acorn gave up on the RTC?
I never heard that decision. I'm guessing it was cost. Or yeah, I don't think I ever saw a System 3 RTC as a circuit board. I've got that circuit diagram, and we wired up one by hand. It's got an Acorn drawing office number on it, but I don't think it was ever turned into an actual Acorn product. It might have been, but I don't think so. There's a note on the corner of the drawing saying you could put Proton speech chips on here too. So somebody obviously thought it would be a useful board to put. Again, that's kind of interesting because that implies they were thinking that the real-time clock could be, you know, if this was going to be the Proton peripherals expansion for the System 3 and the real-time clock was the first thing on there, that makes you think that the real-time clock might have been on the Proton and got thrown off at the last minute. But I've no idea whether that's true or not.
Perhaps that developed into what eventually became the dongle on the level 2 and level 3 systems.
Yes. Obviously that code was sitting there in the file server and had been turned off in the level 2 and got turned back on again in the level 3.
It was there as an option for assembly time, even right up until the end of the level 3 file server, so that it could be assembled for use with or without a dongle. I assume also for testing purposes, where it also gave the date input routine later on, as an aside. So a couple of questions about JCCP. A couple of people are wondering exactly what you're meaning with John CCP. Is this John's CCP or
it is indeed, yes.
Not the SJ CCP? Or
yeah, I missed out a chunk of stuff there that I could have covered. The CCP is what CPM called their command line, or a shell, we'd call it in modern terminology, the thing that you interacted with. So in our first version, if you wanted to do star commands, there was a utility program, STAR. So if you wanted to do star IAM, it was STAR IAM, whatever, which was, it worked, but it was a bit tiresome. So John wrote his own version of the CCP, which had all the standard CPM commands in it, plus support for Econet commands. So the sort of order of development here was you had a machine like the 380Z natively running CPM, booted off floppies. Then we added the stuff to put the Econet primitives and a hook into the operating system entry points so that an extra drive letter, you know, drives A and B with the floppies, and drive E would be the Econet. And so that was all sitting on top of CPM, still using the standard CCP. Then there was John's CCP, done, as I say, to give you a better user interface to the Econet stuff. Then we said, well, if you don't need floppies, then just a little bit of extra code will replace the rest of the operating system. So you could now run our Econet layer, the Econet file server interface, and John's CCP, and none of the original CPM code at all. And we put that in a ROM, and you could boot that into the Z82 processor. So you now had a Z82 processor that looked like it was running CPM, but all the files were coming off the Econet file server, and you could do anything you wanted with that. I used it as my main development environment for, once we got enough file servers to go around, my main development environment for all the stuff I did for SJ was a BBC with a Z82 processor talking to an SJ file server.
And our very esteemed friend Jonathan Hudson is just telling me he still uses JCCP as his preferred CCP when using CPM. So it's just a test to its longevity.
I'm glad somebody's used it. I think he owes us £2, which I think was what we asked for in the shareware license we attached to it.
Well, of course, Jonathan has, of course, slightly tweaked it, as Jonathan does.
Oh, well, yeah. I won't hold him to that.
And it is also available on his mdfs.net website. How appropriate. Trevor did ask about, did the parallel development of Ethernet have any effect on the did the parallel development of Ethernet have any effect on the Econet designs? Or were there other networking approaches that influenced your work?
People obviously knew about Econet, and I'm sure when the first idea of Econet was being floated, Ethernet was in people's minds of, can we do a cheap version of Ethernet? At the time, Cambridge rings were being heavily promoted. Acorn Andy Hopper at the Computer Lab had got Chris and Herman to invest in his plans to commercialize the Cambridge ring. So there was a lot of anti-CSMACD pro-Cambridge ring propaganda going around, but it was known that Ethernet did work. And so, yes, I think Econet was seen as a very cheap way of doing Ethernet. Because at that time, Ethernet was super expensive. That was, 10 base 5 only. The AUI boxes that you use to connect to the Ethernet cable cost more than a BBC micro does. So it was actually using Ethernet was completely out of the question. We didn't look much at it. There's nothing much that you can really say about Econet protocols that directly mirrors Ethernet, other than the general concept of a CSMACD network.
Okay, so slight question from me. So in those early days of SJ that you briefly touched on there, they were interested in the industrial and home automation, and then this piece of work came up regarding the 380s. Was this just a consultancy revenue stream really for SJ in the early days, or how did they go from home automation and automotive interests into Econet, you see?
Well, basically, Kim was setting up this company to do these products, which might well have been successful in those markets. Who can say? I'd met him at Acorn and we knew each other, and he said, why don't we take this on as a sideline? It was, when we got together in sort of November 82 to talk about it, this was definitely, a small portion of SJ Research's business. It was just something, we didn't want this work to get lost. It needs to be commercialized. We'll just, software development will only take a little bit of time. The hardware's mostly done. Just put it on the market and see what happens. As things turned out, it became the product, and but all of this stuff is all about coincidences of who happened to be in the right place at the right time. If those of us hadn't met at Acorn, or if we hadn't happened to pick up if Chris Curry hadn't given Felsted 3 atoms to play with, this wouldn't have happened, and the whole thing could have been different. But life's full of these things.
Yeah, that's right. That's why I just wondered if it was just a fortuitous piece of consultancy that they decided to take on in the early days as a revenue stream, which actually turned out to be a very good move for the company. Fantastic. Any more questions from? Yes, but one just come in here. Was there any back and forth between the people working on Econet and the team working on Cambridge Ring? That's from John Crowley.
I don't believe so. And obviously there were some people who were involved. Carl Della, who did the architecting of the file server, he was a PhD student at the lab, and his PhD thesis was the Cambridge distributed computing system based on Cambridge Ring, and so obviously there was a lot of Cambridge Ring expertise around, but by the time I got there, you know, people like Mike Muller were definitely Orbis people who kept to the, well, for a start, Econet was at Fulbourn Road and Orbis was at 4A Market Hill. So we didn't naturally talk to each other. When we bumped into each other, we really didn't communicate very much. It was, they were perceived as being completely different markets, I think. You know, Econet was all about the BBCs, and the Cambridge Ring was, I don't know how much that money they wanted to charge for you for a Cambridge Ring interface, but I think a Cambridge Ring interface was going to be multiples of the cost of a BBC Micro. So it was just a different world.
And I think then we'll just do this final piece, anecdotal actually, before we take a well-deserved break, because you've been talking and I'm sure you'd like a sip of something. Back to JCCP again from Jonathan. The JCCP credit, JSC Wonder Systems, is then John S. Cox. Any idea what John's middle name is, so I can add the credit to my source?
I believe it's Spencer.
There you go. You know, all the little nuggets of information and anecdotal pieces. Brilliant. There you go, Jonathan. I hope that's good for you. Okay, so with part two, continuing with the story of computers in schools, Econet and his time at Acorn and SJ, we have Andrew Gordon with us. Andrew.
All right, thank you. So to pick up where we left off, so 1983, I'd left Acorn. I was undergraduate. Kim Spence-Jones was no longer consulting at Acorn. He'd started his, well, he'd had his own company for some time, and he'd started turning it into a product company. There was an initial line of home control products, and there was the 380Z Econet board based on work from Felsted School. So that board gave you a CPM operating system client to Econet servers. It gave you a crude level 1 equivalent file server. Company only had 2 staff, Kim Spence-Jones and Tim Whitaker, but there were 3 of us moonlighting, myself, Stephen Lawrence and John Cox. So me doing file servers primarily, Stephen doing Econet primitives primarily, and John Cox doing the CPM integrations, although we all did different things at different times, but at that point, that's what we were doing. And so you can see the mirror with what I said about Acorn in the previous talk, moving from consultancy to doing products, having a one company name and a brand for the products, and lots of outside staff and not many inside staff to begin with, which was the way everyone was doing things at the time. So what was it like at SJ Research? We had an office on Mill Road, a strategic location next door to the Curry Queen for eating dinner in the evening, a few doors down from Harry G, the famous supplier of obsolete components. I once caused great offence when I went in there and asked for a cheap and nasty speaker, and Mrs. G assured me that they don't sell any cheap and nasty items in their store. So I asked for a cheap and cheerful one, and that was more satisfactory. The address, completely coincidentally, was somewhat amusing because we were SJ Research in Mill Road, Cambridge, and the 380Z was made by Research Machines in Mill Street, Oxford. And just a couple of times we got posts for each other mixed up over those addresses. Initially, we had one small office at the back of the building. We eventually took over the entire building from the cellar up to the top floor there, apart from the shop. And the picture is Google Street View now, but the building hasn't changed much. This was much more a shoestring operation than Acorn had become by that time. I'm sure Acorn 3 years previous would have been much more like this. You know, all our desks were made out of bits of timber bought from Ridgeons around the corner, or when we went out to lunch, we walked past the Salvation Army shop, and several times we spotted something interesting in there and brought that home. We didn't even have a kettle. We had a teas made. So you tweaked the clock and it made the tea at the right time. Invoices were done on an Olivetti portable typewriter. So after a little while later, after a slight unfortunate mathematical error in the hundreds of pounds column, Kim's brother, Neil Spence Jones, came on board to manage the commercial side of things. Though, again, in those days, computerized accounting was not a thing, and we did later, but at that time, a company of that size couldn't reasonably consider having computerized accounts. Stephen Lawrence decided that academic music wasn't his thing, so he came and joined us full time and ended up giving us 10 years of his time before he went back to, he's now made a career in music after all, but we're thankful for those 10 years he gave us. And Stephen tells me I must tell the story about the second-hand storage heaters. Which, there was no heating in the building, but it was wired up for storage heaters, so we found some in the local paper advertised second-hand and went and picked them up. Now, normally you transport storage heaters by taking them apart, but unfortunately this vendor wanted to assure us that his storage heaters were good, nothing wrong with them, working fully, so he'd left them powered up. So these storage heaters were red hot and we couldn't take them apart. So we somehow got them in the back of Kim's car and brought them round. So there it was, about 7 o'clock in the evening. We were parked on the double yellow lines outside Mill Road, unloading these storage heaters, which fell apart as we took them out of the car, and the red hot bricks from inside the storage heaters set fire to the bits of cardboard we were using to protect Kim's car from them. Anyway, fortunately, we didn't set the whole place on fire, but it was an evening to remember, and gives you a feel of the sort of small company ethos in those days. Right, back to more proper stuff. So, as I'd said at the end of the previous talk, I'd knocked up a quick file server based on just serving out the CPM disk structure, but that was obviously not good enough. The world wasn't yet talking about level 1 and level 2. It was the proper file server and this other cheap thing, and we obviously wanted a proper file server. So around Easter of '83, I was sitting down to do this, and looking at it here, we decided to implement it in Pascal, which turned out to be a great decision, one of our big practical advantages over Acorn. If people ask why were the SJ servers better than the Acorn servers, I would point to 3 things. We were working primarily in Pascal. Later on, I crunched a lot of it down to assembler for speed and size reasons, but the ability to create the structure of it in a high-level language and edit it and mess around with it was a huge advantage. Whereas Acorn, working in 6502 assembler, it was hard work for them to do anything to their file server, so they generally didn't. Second advantage we had was memory. We were forced to do a recall and revision of the 380Z board because it turned out that the Z80SIO couldn't generate quite the right timing for the line turnaround. The Econet relied on a feature of the 6854 that the Z80SIO didn't have to be able to turn off the line driver at just the right timing at the end of the packet. So we added a little extra couple of chips to our design to get that right. And whilst we were about it, by this time we'd realized that we wanted as much RAM as we could have. So we added 64K of RAM on our on our 380Z boards. So all our file servers had more RAM than the Acorn ones. And our third advantage, which I haven't put on the slide, was we were closer to the customers because we were a small company. So there wasn't a sales and marketing department and a technical support department. The customers talked to us, and we found what the customers liked or didn't like, and we were able to go and tweak the file server to suit. Whereas Acorn by that time had grown sufficiently big that ordinary customers didn't talk so much to the technical people. So really, that's, you know, right from the beginning, that's the genesis of why SJ file servers were, you know, better than Acorn file servers, because we had those three advantages. In terms of the design I came up with, this was a while spent doodling on the whiteboard and in the office there. To, you know, I wanted to keep the same allocation block size as the Acorn servers did, but the numbers just didn't add up. So I ended up with something with a 1K block size, 16-bit block numbers, which gave you a maximum of 64 megabytes, which was enough for those. You know, most systems run out of steam and regret their top number. I don't think we ever did. You know, for a long time, we weren't even allowing 64 megabyte. We were partitioning it down for other reasons, and even at the end, that 64 megabyte wasn't a constraint on it. We'd have needed more RAM and more other things, so that worked out well. The way that then worked out to get you one level indirect meant that the maximum file size you could have was 8 megabytes, as against the protocol allowing you 16 megabytes. But again, if you've only got 64 megabytes total, not being able to have files bigger than 8 megabytes was never a practical issue. So the Acorn server on floppies, the 256 byte block size probably was a win, because you got more less wastage, and on a small floppy that was probably valuable, but we got more performance, and it grew more easily. So overall, those numbers all worked out rather well. And we added all sorts of minor features as we went along. Again, this was out of talking to customers and seeing what they wanted, and or seeing what was possible and thinking what we could do. So the no short saves was definitely a customer feature that, you know, schools were finding that people's lost their work because they'd press break and type save, and they'd overwrite their program with a 2-byte empty program and lose the previous version. So no short saves just meant you couldn't save a very short file to stop you doing that. The default access, wildcard rename was my, well, took more effort than anything else in the file server and generated more bugs than anything else in the file server. I hope people enjoyed it. The way you could rename with wildcards on both the source and destination, with the multiple fields in the left-hand side getting replicated into the right-hand side, and you could rename between directories, and you could rename directories, and yeah, it was the world's best rename. Whether you wanted the world's best rename or not, I don't know, but it was, we did. And we did space accounting, which Acorn originally didn't have, and when they did add it, theirs was less sophisticated. Ours was based on an account number system, which was a lot like Unix user IDs, although I'd never been exposed to Unix at the point when I was designing this. But I guess it's only a limited number of ways in the world to do these kinds of things, and that also worked quite well. So a little bit more home automation happened that year. The next BBC series, I think it wasn't actually making the most of micro. I think it was the one after that, because we were filming in summer '83. We had automated Paul Bond's house with all kinds of gadgets. We got strange noises out of his gas boiler because we were trying to control that with a BBC micro. And my main memory from that day when they were filming was McNaught Davids, the presenter. He just loved the fact that we'd got this voice recognition unit and he could swear at it and he would get the machine to swear back at it. And he enjoyed embarrassing the young women who worked as production assistants at the BBC by swearing at the machine and getting it to say rude things at them, which I thought was a bit off at the time. But, so that was that. We sold some R2s and control ROMs to British Leyland and they couldn't be bothered to pay for them. That was the only bad debt we had in the first many years of the company. That we should probably have taken them to court, but we couldn't be bothered and they couldn't be bothered to pay. So that was unfortunate. Gradually, the Econet products took off and there just wasn't time and effort to be spent on the control ROMs. On any of the control products. So the control ROM, which as I mentioned was written by Peter Miller, who did the sound in the BBC OS, he'd got his own little consultancy company like everybody else, and he was making products, so he took back the control ROM and went off and did that. Paul Bond took the prototype of the lighting controller to have as his own toy, since we were no longer proceeding with that project. The R2s stayed in production for a while. They're very useful. I've still got a couple in the cupboard and use them from time to time when I want to control something. And as a side note, after the whole of this, everything I'm talking about today and what we did in the company after that, Kim eventually at the end of his career went back to do home automation. So it was obviously in his blood, even though we steered him away into networks in the meantime. So, summer of '83, the 380Z was selling nicely. There was a clear need for a hard drive file server. Felsted had already blown their budget on a big hard drive a while back with the attached to the NASCOM. That was probably the first hard disk file server on Econet, because they would have had my CPM file server on that fairly early on. I think before Acorn had built any hard disk file servers, certainly before SJ had built product hard disk file servers. We thought about doing a hard disk add-on to the 380Z to do a hard disk file server that way, but that would have been a bit of a dead end. The 380Z was a bit of an old machine by that point, and we didn't want to give sales to research machines. So we decided we needed to build a dedicated file server, obviously using all the Z80 technology that we'd already got lying around. So it was a dedicated server unit with 1 or 2 20 megabyte hard drives. They were not SCSI, they were, well, the drives were controllerless, and you had a SASE controller in those days, because SCSI was just about being invented around that time. We invented StarFast as the way of doing the admin interface to it, because obviously we didn't want to give it a screen and keyboard, and we didn't want people to have to attach a dumb terminal to it. But FAST stood for fast remote, because obviously we could have done it with Star Remote, but Star Remote was a bit slow, and we wanted a better terminal, so we wrote StarFast. We believed that you needed tape backup. We believed that backup was important, and people couldn't be bothered to do backup on floppies normally, and doing a backup of a 20 megabyte drive onto floppies would never get done. So we felt you couldn't live without a a tape backup. We had a really nice tape drive that we'd considered, but that was just way out of budget. You know, it had a SCSI controller that was as big as the drive, and it would have been lovely if we'd been able to use it, but we couldn't afford it. So we ended up with this floppy tape thing, which took standard quarter-inch cartridge tapes, but presented a floppy drive interface. So when you stepped the head of the, or stepped what you thought was the head of the floppy, the tape would wind forward by so many centimeters, and it would run the tape under the head, and you decode it with the electronics that you would normally use for decoding data off a floppy. It was a bit flaky in the end, but it worked just about. That was the weakest point of the file server. Obviously, we didn't discover that till we had field experience of it. So in terms of the design, having decided it was going to have hard drives that were expensive, it was going to have a tape that was expensive, the whole thing was obviously going to be very expensive. So we thought, if you're going to make a product that's expensive, make the best product, not something cut down. So we put everything into it. To be honest, we went over the top. If you read the Mythical Man Month, I think we suffered from second system syndrome, but we gave it 2 processors, which was going to be a Z80 for the file server and a 6502 for the control, but our prototype, the 6502 at 3 megahertz, was flaky, and we went back to 2 Z80s. It had a completely separate cache memory with a DMA controller to drive it, with all the peripherals hooked up to that. It had loads of RAM. It had 128K on one processor, 64K on the other processor, and 256K of cache. It even had a hardware widget for finding groups of adjacent free blocks in the free block list for optimizing the disk layout, which was completely pointless. The second processor could have done that, or the first processor could have done that without too much trouble, but it went in. It was only a few gates. So there it was. We launched it in January '84 at the BET exhibition with just a wire wrap prototype. And by the by, I mentioned Brian Jones wire wrapping electrons in the previous talk. By 83, 84, I can see from the edit list on the circuit diagram that it was Brian who was building the wire wrap prototypes for the HDFS for us. The BET show became the heartbeat of our whole business. Every year, for quite a number of years, we launched a new product of one sort or another at BET, which was always held in January, which meant that we were always working over Christmas to get whatever it was out the door. Some years it really was out the door. Other years it was a typical demo system, which was in one degree or other faked up. So that year we had an HDFS as a wire wrap prototype. We actually delivered to the first customers in July. As a side note to all of this, the RAM prices had crashed around this time, and we actually considered forget the hard drives and do an entirely battery-backed RAM file server, because if you're going to have a tape drive so you can back it up, then the difference between RAM and disk drive, the fact that the disk drive is more permanent doesn't matter, and the disk drives are expensive and their controls are expensive, and the power supplies for them are expensive. You take that all away, you could almost do one out of RAM, but the numbers didn't quite add up. There were a couple of times over the years we looked at it and we looked at it again, and we thought if the price just came down a little bit further, we could build that RAM file server, which would have been the ultimate fastest file server you ever have. But it never did quite. So how did we sell to schools in the 1980s? Worth mentioning here the DTI Micros in Schools scheme from 81, 82, which really was not a lot of money, but that was what kick-started things and meant that there was a market there for us to sell to. It only funded one machine per school at 50%, but it got people getting machines and finding sources of funding and thinking, having got one machine, thinking about how they were going to fund the next one. And it forced people to take sides in the 380Z versus BBC business and made the market those two systems only. So it was, as I say, not a lot of money, but it was very influential in setting up what shape the market was. The local educational authorities were and remain for the next few years very important. They controlled most of the money for state schools. Their power wasn't absolute. You would find some, and it varied from county to county, some had very strong central control, others gave, we would find we would be able to sell to an individual school who wanted something better, like the LEA policy might be Econet, and most of the schools would buy Acorn file servers, but one of them raised a bit of their own money and bought one of ours. But in general, we were selling to LEAs to get the message out there that Econet and our file servers were what people wanted to buy. I've mentioned the BET show as being the place to be. A lot of sales flowed from that, not necessarily immediately, but that's how you got your name in front of people. Press advertising worked. What was the magazine called? Educational Computing. We advertised in regularly, and it must have worked because otherwise the 380Z products were already selling before the first time we went to BET. But another big thing was the users selling to themselves. A group of our early customers, or particularly one school that we'd sold an HDFS to, set up the SJ user group, and lots of schools got together and exchanged, they ran their own conferences and they ran a newsletter and they exchanged software tips and so on, and the existence of all that spread the message. And there were people like Chris Dawkins at Felsted, again, getting teachers in, showing them what he'd got, making them think that they wanted to have the same. We sold quite a lot through dealers, which was a mixed blessing. Obviously we had to give away commission, and in some cases they provided good support, and in other cases that just meant that the support came back to us, and in worse still cases the dealers gave the wrong support, and by the time the queries actually came back at us, the customer got fed up and was doing the wrong thing. But the good dealers were good, and people needed somebody out in the field to do installs and so on for them, so we did quite a proportion of business through dealers, and some of them were very helpful to us. The thing on the right is the front cover of the materials from a conference that one of our dealers, ME Electronics, ran in 1986. They got everyone who was anyone in the Econet world to give presentations there. So Kim and I were speaking on various technical things. Lawrence Hardwick from Acorn was telling you about the futures of Acorn's products, and so that there was a lot more selling done through conferences and things than there was through advertising. And a slight aside about that particular dealership, our customers, there was a reasonable gender balance between them because we sold to girls' schools and boys' schools, and there were quite a number of our end customers were women. All of our dealers were 100% male in those days, because that's the way technology was, apart from ME Electronics, where they were 100% female, which and they were very effective. They were probably the most effective in terms of selling out of any of the dealers we dealt with. So we ended up, they were based in Reading, so we ended up with a lot of business in the Thames Valley. I spent a lot of mileage driving from Cambridge round I can tell you the history of which bits of the M25 were built when, because I was traveling frequently down that way. Schools doing a lot of their own software, and educational software beginning to come onto the market around these times. So before the BBC, there wasn't much of a commercial market for software. With the BBC, there was a commercial market, and there was also a self-help market, and semi-professional software like schools would sell at a very cheap price the things they had, just because they, software was perceived to have a value. So sort of selling things for £5 or whatever. And the final thing we did on the marketing side a bit later than this, we did a teacher job share with a local school, which was Kim's old school, which is why, well, it was local and it was Kim's old school, so it was the obvious school to do it with. So we had a teacher who worked half-time at the school and half-time for us. And we went around about 3 different people who started off doing their job share and ended up working full-time for us. And we found another of our customers who was a teacher who wanted to come into this job share and so on. So we got Alice Shimmin and George Hawes, and somebody else came in through that route. So that's how we sold it from our side. Why did the schools buy the Econet? In the early days, it was absolutely about cost. People couldn't bear to have a classroom full of cassette machines. Actually getting a class to load their work off cassette into the machine and save it afterwards, by the time you've done that with a whole class of pupils, you've spent the whole lesson loading and saving and not done anything. Floppies are too expensive and Econet is cheaper, or at least that was the straight cost comparison. A floppy drive on every machine or an Econet interface on every machine plus a file server. The Econet is cheaper. That was how it was decided for a lot of people. We knew that networking was good, but in the beginning, it was purely a price thing for 90% of our customers. There was also a lot of upgrade business where people would have had one BBC through the DTI scheme or a couple of machines, and then as they got more machines, they realized that they couldn't support them without either disks or without either floppies or network, and they got network. Indeed, that was a sufficiently significant business that if you look at Acorn's prospectus for the share sale in '83, Acorn listed as one of their main areas of potential business for the company was selling Econet upgrades to the non-Econet BBCs that they'd already sold. Print server requirement was also a significant thing. Again, can't afford a printer on every machine, and printing out of classwork was a requirement. So it was all about providing print and disk to every machine cheaper. Then after a couple of years, it began to shift. People began to realize that actually, once you get beyond one room, the manageability and making the machines more appliance-like, more student-proof was actually more significant. If you leave a BBC with floppy drives out in the corridor or in a common area for people to use, it will get not vandalized maybe, but it will mysteriously be no longer working. Whereas the Econet machine with no moving parts, control brake, shift brake, gets you back in, all the stuff's set up carefully on the file server. If the machine breaks, you swap it with another one. That management aspect became much more the selling point as time went on. And people began to realize that although Econet costs money to install and it costs effort to manage it and set it up, but that's bounded effort. Once you've done it, it's there and reliable. Whereas working without Econet, was, you know, continuous strife every day. So there was a shift in the way people thought about it. And later, quite a lot later really, for it to be widespread, people began to exploit the potential as a comms network. Things like the teletext server, a bunch of other things I'll mention in a minute, but probably not as much as it could have or should have been, but it did get exploited. And probably those applications that did exploit the network were more about communication via the file server, so programs that saved something on the file server and accessed it from more than one machine, rather than a lot of applications doing real direct Econet, which doesn't matter. It did the job. So back on the timeline, in March '83, we made the SJ clock and terminator boxes. Now, we never intended to make these. Who would bother making them? Acorn already sold them. They're a very boring product. Why would we go head to head with Acorn when we got more interesting things to do? However, we got a phone call from a potential 380Z customer, and we were really keen to get the first few 380Z customers out the door. And he said he wanted to order from us. He wouldn't place the order till he could get some clocks and terminators, and Acorn were out of stock and couldn't tell him when he could get them. So we scratched our heads a bit and we said to him, well, look, we'll knock you up something crude. It'll just be a naked PCB, but it'll work. It'll get you going. We'll charge you half the price of the Acorn one, because it's not going to be very pretty, but it'll do the job. So a week or so later, the order rolled in and we thought, now we've got to actually make this thing. And there was a very inventive period of a couple of days when someone would start sitting down to design something, and then we'd go out for lunch and have an idea, and we'd go out for a curry in the evening and another idea would come up and the prototype would appear. And we ended up with something that was really quite different to the Acorn original. I think when we made the offer, we were thinking in our minds, we'll just clone the Acorn one and that'll be it. But the Acorn one used an off-the-shelf baud rate generated chip that gave you about 20 different baud rates you could select, of which only 2 were actually useful. So that was a relatively expensive chip and it wasn't very useful. So we decided to build it out of TTL. And that caused us to think, now what do we actually want out of this? And that led us to the variable multi-space ratio stuff, because we were thinking about long networks, having built the ones at Felsted and other places. And because we were building it out of TTL and we had to think about what waveform we actually wanted to generate, we came up with that. The original Acorn terminators, you'll remember, had power supplies to them and our terminators didn't. That came because Tim Whitaker, his job immediately before SJ had been at the Royal Opera House, where he'd built them a whole bunch of audio microphones with phantom powered microphone preamps. So he immediately said phantom power for the terminators, and that was such an obviously good idea, we just did it. It's got dual outputs when the Acorn clock had one output, because if you're using a 75159, you've got 2 outputs for free, so why not get the better signal quality that you'll get by not splitting it. And somebody came up with the idea of putting it inside a DIN plug as an enclosure. We were originally going to pot them, but the potting compound leaked out all over the desk, and we decided that actually a piece of sleeving was good enough. The picture in the bottom very left corner is slightly interesting. You can see it's got a torch logo on the end. I'd entirely forgotten about this, but we obviously, I do remember now, we did Torch branded ones for Torch doing their TorchNet stuff. And it must have been early on, because that one has a Torch logo on it and is the skinnier type of DIN plug compared to the fatter one in the next picture that was what we used for the bulk of the production later on. And as I say, I'd forgotten that, but it was sitting in the network underneath my workbench for the last 30 years. When I got it out to take a photo for this slide, I spotted the torch logo. So that's clocks and terminators. Socket boxes we hadn't done at that point. We just said, well, you take a DIN socket and you put it on a faceplate and you solder to the back of it. That's what you do. That's what we told the customers. But I had to go and do an install at a school in Wiltshire. We didn't really offer the install service. We prefer people did it themselves or got dealers to do it or whatever, but occasionally people twisted our arm or said, if you install for us, we'll place an order. So we always said yes. And this was the first one. And we thought, I've got to do this in a day trip. How am I going to do this efficiently? So Kim sat down and made me some socket boxes with ordinary DIN sockets that we'd bought from Harry G, riveted onto the front of a standard Veribox and a bit of tag strip in the back. And Kim spent all afternoon doing that and thought, blimey, that's a lot of work, but at least it'll be easy for you once you get on site. And I got on site and I did all the wiring and I soldered it to the tag strip and so on. And it took me ages and it was a long day's work doing that. So we got back to the office the following week and we thought, this is really hard work that we're asking our customers to do. There must be a better way to do it. So we made the socket box, and it's got those insulation displacement terminals in, which are the same as in BT telephone sockets, because of course we just had a telephone line put in, and you know, these BT sockets were a new thing in '81. As I'd said on the previous slide, all telephones were hardwired up until that year. So we just looked at, you know, we didn't leave the BT engineer to get on with it. We'd had our noses in what was going on there. And then when we came to do the socket boxes, we thought, aha, yes, we could use that same technology. So we did. So we had all these nice installation products and these superior clocks and terminators. And the Acorn salespeople started sending customers to SJ, which was obviously a bit embarrassing. So they thought they ought to have a set of Acorn products that did this. And so we negotiated with Acorn and they drove a hard bargain. Ultimately, although we'd agreed a price that was low, but we could just about live with, they insisted on contract terms that would have let them kill us. That, you know, basically we'd have placed orders that we had to pay for, and if they wouldn't guarantee to pay for the stuff that they ordered. So we just couldn't accept the contract terms, and the deal fell through, and we never sold them to Acorn at that time. So Acorn made a clone of our products. I've always wondered whether the technical guys, given the job of making those, deliberately made it a, you know, half-baked job, because every aspect that they changed that wasn't identical to ours, they made it worse. They had the luxury of custom plastics, yet they made the box exactly the same size as ours, even though it was a bit cramped inside, and they made it, yeah. There's a whole load of things that they did change, and every single aspect that they changed was worse than the original. So whether that was just couldn't be bothered or it was deliberate, I've no idea, but it meant we made a healthy business selling clocks and terminators that really we shouldn't have ever had. Another product we sold that wasn't really part of our business was sideways RAM. We were far from the first to make a sideways RAM, but one day a salesman rolled in trying to sell us chips, and he had these modules. Yeah, it was at that point you couldn't make a sideways RAM by just putting a standard SRAM chip in the sideways ROM socket because the biggest SRAMs you could get were only 8K and you needed 16K. But here were these little modules that looked like a 16K chip made out of 2 chips. And we just needed to add a flying lead to pick up the right line, and you had a sideways RAM that was very easy to fit, very robust, because some of the other sideways RAM products on the market were all very featureful, but they were very wobbly and not really robust enough for school use. So we made this product. We sold a reasonable number of them. There was a suite of software to go with them to load your images in, which somebody at the engineering department wrote for us. So that was a very minor product for us. Lots of other people sold sideways RAM. Probably more of our customers bought them elsewhere than from us. But sideways RAM with the ROM images on the file server was again significant in making the BBC an appliance-like machine where you don't need anything around the edge. Control brake, shift brake, you're into whatever software you need to run without any messing about. Okay, so we've moved on another year. It's coming up to BET again. We need a new product. The HDFS was wildly expensive, although it had a broader customer base than you might think. We weren't just selling it to rich private schools. We sold quite a few to ordinary comprehensive schools. But lots of people told us it was too expensive, and they were right. So we decided we needed to go to the opposite extreme to make the cheapest dedicated file server that's still a full spec machine. Because again, by this time, a lot of people were running the Acorn level 1 for cost reasons, and it wasn't a good solution, and we wanted to upsell them, or indeed for them to go to Acorn level 2 was took out a BBC and a second processor. It was quite an expensive thing, so we could build something of similar cost that was better. So we did. So the FDFS took us same Z80 Econet circuit, just 128K of RAM and just one processor this time. No built-in devices. It had the connectors on the back to suit standard BBC floppy drives. So if you'd already got a BBC file server, you could take the floppy drives off that, put it into ours, run them at double density, which if you were using DFS and an 8271 on your BBC, that was single density, and the ADFS and the 1770 controllers on the BBC hadn't really appeared yet. So that was a step up in capacity, even with your existing floppies, that if you bought our server. And we also supported quad density floppies, which were, well, the ones in the picture are quad density, though you can't tell the difference from looking at them, but they ran the same parameters as an 8-inch floppy, but physically the size of a 5-inch floppy. So that got you 1.2 megabytes per disk. So that was, and we supported a total of 4 drives. So that was really quite a lot of capacity for a floppy-based file server, and a big step up from level 2. And it had all the same features as basic features. It had the parallel and serial printing. We controlled it with the same star fast, and at this stage it was still, in fact, exactly the same file server code as the HDFS. And this time at the BET show, we not only had a prototype, we had fully working units. We had 10 production units ready to go. It was, I think, the first and last time we were in that good a position come January. So what were the competition up to? Research Machines with the 380Z had eventually come out with the 480Z, so they were about a year behind Acorn, with a similar price machine to the BBC. They also came out with a network, which they bought in. ZNet came from Zilog, the processor manufacturer, and the operating system was CPNet that came from the makers of CPM. Their network had higher performance slightly, but it was based on coax cabling like 10-base-2, and it didn't go very far. And they never really seemed to do the same kinds of things with it that people did with Econet. It was, well, obviously I didn't see what everybody out there was doing, but as far as we could tell from our side, it was mainly confined to single room type installations, not site wide, and the software was mainly confined to just being file server and print server and not doing anything more adventurous with it. But they sold a fair quantity. Apple, later on, laser writers appeared here and there. At the beginning of this story, when we're talking about BBC Micros, the Apple II was a competitor, but it didn't take off in the UK. In Ireland, it did, because they were insisting on Comal rather than BASIC, and it took a while to get a Comal language for the BBC. So there were more apples going on over there. And later on, when Apple meant Apple Mac rather than Apple II, it was quite popular as a single machine, but people couldn't afford class sets of Macs, and so it wasn't a big competitor. In terms of our competitors within the Acorn market, obviously the Acorn Level 3 was there, but for reasons that I already discussed, it was not a big step up in feature-wise over Level 2. So we were competing with them on features. DSL, Digital Services, who I think were the people who later went on to do the Squirrel database on Riscos, they were selling something that used the Econet hardware but wasn't Econet compatible. I don't know why, because the Econet stuff was all publicly available if you knew where to look. Anyway, they did their own thing, and that was a significant competitor to begin with. Obviously, the other competitor was just not doing Econet, people just using floppies or cassettes. And I think there was somebody else doing some kind of networking, but that's escaped my memory, and they weren't a big part of the market. People thinking of buying our stuff, mostly if they decided not to go with us, they went for the DSL disk server. So in '85, we finally got the software on the HDFS to really exploit all those crazy bits of hardware that we've provided. So at this point, the HDFS diverged from the FDFS and NASCOM. The new MFS file server was multi-threaded, which was really significant for performance, because you could serve a request from another client whilst you were waiting for the disk transaction to complete for the first client, and as opposed to some file servers that wouldn't even accept the packet. So you not only were wasting time, but you were also wasting network bandwidth by not queuing these requests. So that was a significant win, which was possible because we got that much RAM. We did print spooling on top of our print server that was already enhanced over the original. So we had multiple printers by name with different banner pages printed at the front of them. So you could select the same printer with different names to get high quality or low quality. And we had online random access to the tape, though this was a kludge, and the kludge worked so well that we never got around to implementing what we'd originally planned. We'd originally planned a sort of batch job system where you could request bits to be fetched off tape, and the server would go on and do that for you and come back later. But we never implemented that, because we implemented the quick kludge of letting you just access the tape with random access very slowly. And because we got so much cache memory, that actually worked, and people lived with it, and we never got around to doing the proper job, unfortunately. Not strictly part of the file server, but part of the overall offering. The suite of library programs that shipped with the file server was gradually growing. And later on, this fork of the software increased the number of user accounts from the original 256 to 2048, because people were getting systems with enough users that 256 users registered was becoming limiting. And we let you edit that in a complicated way with preparing offline text files containing all your users and merging them in, which was extremely hard work, but it was less hard work than typing in 1,000 usernames by hand. Meanwhile, at Felsted, what was going on? I mentioned display electronics just for amusement, or for reasons that will become real obvious in a minute. There was no eBay in those days, but there was an outfit called Display Electronics with a Aladdin's cave in a warehouse in Croydon where you could buy secondhand stuff. So Felsted bought lots of monitors there, as they wanted to stretch their budget to get as many BBCs as they could and not economize on the monitors. In particular, they bought some monitors that turned out to be ex-Reuters, used for Reuters data terminals in City of London dealing rooms. They wrote a notice board software, which was a thing where in the corridor would be a Mode 7 display, so everyone walking past could read notices. Mode 7 was ideal for this because it was big enough and a small enough amount of information that people could read it walking past. You know, if you'd had high resolution screen, then people would have had to stop and read it and it wouldn't work. It was split into 4 sections for the headmaster, the staff, and a general anyone can edit area, which you would think would be full of people writing obscenities and things, but actually they quickly learned that they would get found out if they did that, because the security on the network was good enough so that that worked. You could go to any terminal on the network, you could put your notice in and it would appear in the corridor and everyone would see it. So that was another part of Chris Dawkins' idea of getting people who weren't into computing to be using computers in their daily life. If they wanted to put up a sports practice notice, they would go to a computer and they would type it in, and that might be the only thing that people ever wanted to do with a computer, but it got them using computers. Likewise, the teletext server. People who wanted to check the cricket score or the horoscopes, again, were not the kind of people who were heavily mathematical and into using computers, but because the computers provided a useful service, it got them their computer literacy by the back door. There was a thing called the chat system, which provided a sort of Twitter-like short message sent to groups of people. There was an internal email system. There was a boot menu. Everybody wrote a boot menu because, again, the big benefit of the BBC Micro on Econet was this appliance-like behavior. You could have machines all around the place, nobody needed to look after them. You walk up to a BBC machine, control break, shift break, you're into a menu, you pick an item off the menu and you're doing what you need to do. So everybody with an Econet either wrote one or pinched one from somebody else who'd already got them. And that was the key part of the user interface of Econet. So all the applications I've just listed up there were Felsted things that they shared around with other people. They also had a whole load of internal applications. They were still computerizing the school role. And again, if you want to look something up in that database, doing it on an Econet BBC was faster than it is today, because you just walk up, you press a few keys, and it's immediately on, and it's immediately there, faster than you can get logged in and connected on even on a modern machine. By 1985, Felsted had 4 kilometers of Econet cable active, and they've got, I say bought with a question mark. There was some degree of flexibility between us and Felsted. Sometimes when their budgets were flush and we were doing not so well, they'd buy equipment at full price, and sometimes when their budgets were poor and we were doing nicely, we would slip them free equipment. And obviously software and ideas flowed to and fro. So obviously not an SJ thing, but the next thing on the timeline of what happened to Econet, the master came along in 85 with ANFS, which solved the problems of random access files being slow if people hadn't written the software with a view to running on Econet. Though unfortunately, because most places had a population of BBCs and didn't go to pure masters, not much software could take advantage of that to begin with. Although there were kludgy solutions for doing the equivalent of that on ordinary BBCs. Somebody at Acorn had the bright idea of pushing the Econet on a plug-in module, which was good in some ways, but not in others. Initially, they didn't socket the line driver chip. They expected you to throw away the whole module if it got blown up, which happens sufficiently often that was not a sensible idea. Later on, they went into sockets. And someone at Acorn decided to take out the collision detect. I'm not sure who, but it was a bad idea because it meant that broadcasts became unreliable. It was fairly quickly put back again when we, among other people, grumbled about it, but the early versions of the master Econet interface dropped the collision detect. The master ET formalized what had become very popular in schools at that point. You didn't need a Model B. What you needed was a Model A plus the extra 16K of RAM plus Econet. That was a very popular thing to buy. So the master ET let you buy the equivalent of that off the shelf rather than having to put it together yourself. And a bit later, the master compact came along, but it did work on Econet, but it wasn't particularly popular as an Econet station because it was based around having a floppy in the enclosure, so you were paying for that, which you didn't need if you were on an Econet. Another thing happening in 1985, the Econet Standards Group. I'm not exactly sure why Acorn suddenly did this. There was a DTI initiative on a national LAN standard, which never came to anything, so maybe that sparked it, or maybe Acorn were just wanting to promote their technology as being more open. Anyway, this group was convened with SJ and Torch and Acorn and Reuters. It standardized things like what characters were allowed in a file name and standardized various of the protocols that we had exchanged informally before. Torch was represented by Clive Feather, who was another Felsted pupil a couple of years older than me. And I discovered, reading the minutes of that I dug out of my filing cabinet last week, that Acorn had been doing a PC Econet card with no CPU on it, which I'm not sure I knew at the time, but explains a few things. So we did do a PC Econet card. Now, the story behind this was that Reuters needed it for modernizing City of London dealing rooms. Reuters had got lots of these different information services that you could have, each which had its own terminal, single user, one terminal per service, like those monitors that ended up scrap at Felsted. And they wanted a more modern system where each desk would have one monitor on it with software pulling together the different services. So the services would arrive in the building on PCs, the PCs would have Econet cards in, and BBCs would put the data together and provide the video. So I now think that they had originally agreed with Acorn to do it, although I remember Chris Oswald, who you may remember from part 1, was doing teletext with me and back in Acorn. He bought me dinner at one point to talk about this stuff, but I think they were planning to get Acorn to provide all of it. And then suddenly, late in '85, they came to SJ and saying, we need this, panic, panic, must have it by the end of the year, which we really didn't want to do. We were busy with our next product, but money talks, so we did it. And you can see the board there, so it's quite a busy board. It was done basically money, no object. It's got to be done by the end of the year. It's got to be done, best performance we can get out of it. All the logic went into PALs. We'd had good success with all the other Zilog Z family chips, so we used the Z-FIO, which is a FIFO chip, a bit like a tube, which seemed like a good idea until after we'd built it and we discovered the errata list, and the wretched thing hardly worked at all. So we delivered this thing to Reuters on time, but it was an expensive board, which would have been worth it if it had been super high performance, but in the end it wasn't. Acorn did their own version about a year later, which was not a native Econet on the PC's CPU. It was just like ours, an intelligent board with a processor. Obviously Acorn's one was 6502 based and ours was Z80 based. Theirs used shared memory instead of our FIFO approach, but we agreed a common API to the Econet transmit and receive. So I'm now thinking, having read those minutes, that Acorn were originally doing one native on the PC CPU, that they tried that and they never got it working, and Reuters came to us to get them out of the soup. But I don't remember that from the time. I just remember Reuters asking us for it and we did it. So a bit later, when Acorn had done their own card, John Cox then did the MS-DOS integration. So this worked, as seen by the user, in a very similar way to how the CPM stuff had worked, that you had an extra drive letter that would access Econet file servers from your MS-DOS machine. Under the covers, this time it worked using Microsoft LAN Manager to get you the hook into the operating system, and then we did a protocol translation in the driver. John and I can't remember whether that was a contract for Acorn or whether something we delivered on spec and or developed on spec and sold to Acorn. We think it was probably contracted by Acorn. So when we were doing that, we should have been working on this, the SJ MDFS. One of our customers had come to us, or at that time he wasn't a customer, he came to us to look at the HDFS, and he said, what you've built is a Rolls Royce. I don't drive a Rolls Royce, I drive a Ford Cortina, he said. Make me a Ford Cortina and I'll buy one. Meantime, I'm going to go and buy one of those DSL disc sharers because they're not as good, but they're cheaper. So this was the answer to people who said the HDFS was too expensive, and indeed Mr. Ford Cortina did buy an MDFS from us and scrapped his DSL system. M stood for modular, so it could do anything that the FDFS or the HDFS could do with all the drives in separate boxes. So you could start with a set of floppies and expand up to a system with lots of hard drives. We cut down the spec from the HDFS, which ended up with nearly the same performance with much less electronics. I wish we'd had the chance to do a better HDFS, but there was never a market for it. So the MDFS was cut down. We knew then, if we'd had the same amount of money to spend as we'd spent on the HDFS, how we would have done an HDFS better. But it turned out we could get most of the HDFS performance with much less hardware. So single CPU, 256K of RAM, supports 4 floppies just like the FDFS, supports external hard drives, which were now SCSI rather than SASI because time had moved on. And this time the tape drive was a real SCSI tape drive, not a floppy tape. We had a real issue of what to do about hard drives, because obviously we had to supply our branded hard drives. We needed to charge significantly more than we paid for them to give us margin for support and service and overhead and so on. But users know what hard drives cost, and they can buy commodity drives from other people who are making them in much bigger quantity, the likes of Qmana or whatever. So they expect to get the same price from us, or they buy the other drives and they still get the support from us that they're not paying for. In the end, we decided we had to let people use third-party drives because that was important to increase the size of the market. Our drives were a bit more expensive. A lot of people who had bought the DSL systems could now buy the HDFS, take the hard drives they'd bought from DSL and plug their hard drives they'd already got into the MDFS. So we had to give up that potential profit on selling hard drives to keep the overall cost down and provide that upgrade route. The tape drives, on the other hand, we decided there was a lot of development work in supporting tape drives, so we decided that the tape drives would be locked and you had to use our tape drives. The locking was simply done as we took the EPROMs out of the tape drive, and where the manufacturer string said 3M, we changed it to 4M, and our software checked for that and didn't work unless you were using the modified ROM. People grumbled about that, but they had to live with it. Whilst all this had been going on, bridges appeared. This slide's a bit out of order because it collects all the bridge information, which covers quite a lot of years. So the idea of bridges to have multiple Econets so that you cover bigger sites and more stations, it had been in the design almost from the beginning. It wasn't in version 1, but it was in version 2 by 1981. The first bridge was released in 1984. It was done by Brian Robertson. Unfortunately, it was done at the same time as the master Econet modules, and so it picked up the same no collision detect mistake. And unlike the master modules, it was never reworked, or at least not until much later. So broadcasts over bridges have been unreliable. We had one customer who wanted an opto-isolated bridge, so we got a standard Acorn bridge and put opto-isolation components on it. You'll notice the same design appears if I go back a slide or two. Yeah, if you look on the PC Econet slide, and those white blocks in the top right-hand corner is opto-isolators. Basically, we'd done it once for this customer. We put it on the PC Econet card because that was a cost no object card. So we've got this piece of technology lying around, so it went in. We also put it on the circuit board of the MDFS, but we never actually fitted it for cost reasons. So some people I've seen speculating as to what all those extra component locations are for. It's for opto isolation of the Econet. The killer stream bridge was a thing for bridging between multiple sites. I don't have an exact date for that, but at that conference I mentioned earlier on, run by ME Electronics, Lawrence Hardwick's talk was previewing the killer stream bridge at that point. I think initially it was an internal Acorn project, and was by this time Acorn were on multiple sites at Fulbourn Road and Newmarket Road, so that linked their internal Econets between multiple sites. By 1989 they'd sold it to some external people, in particular Broadland Radio were using it to link their radio stations together, and it was being a bit unreliable, so they gave us a consultancy job to make it work. So we did. That work also included improving the performance and stopping the bridge stomping on broadcasts greater than 8 bytes. Because the original Econet design had an 8-byte broadcast, and various things that were being developed around that time wanted to do bigger broadcasts, and you couldn't do it because the bridge, after it received the 8th byte, would prepare to turn the line around and transmit in the other direction, so it would stomp on any subsequent bytes. So that got fixed as part of that work as a consultancy job by SJ for Acorn. And quite a lot later, SJ took over the bridge altogether from Acorn and produced the Ben, which we'll come on to later. Finally on this slide, the joint. This was a thing invented many times but never actually put into production. I was going to tell you that nobody ever built one, but when I was preparing for this talk and dipped into my filing cabinet, I found not one but 2 circuit diagrams of joints that people had built and claimed were working. So the idea with joint, unlike bridge, which was a logical thing that received the packets into the bridge and then copied packets out onto the other side based on the addressing, the idea of the joint was that it worked entirely at the electrical level. It just echoed the signals onto a connected network, which let you get away from the limitation that Econet has to be all in a straight line. So you could build a T-shaped network with a joint at the middle, which would save you, keep your cable shorter, let you run it faster. If it worked, it would have been a great idea. But, well, as I say, it was discussed with many people at many occasions, and I never saw one working, but I have now found that 2 people at least built them. I presume they tested them and they didn't work. Large installations. So by this time, we've got quite a lot of customers, some of which have got quite a lot of BBCs on quite large sites, and we've gradually done various work to support them. The cable type was an issue. I don't know how this arose at Acorn. In the very, very early days, Acorn said use any old 4-core you like, it's easy. And then when performance seemed to be a problem, they picked a particular cable type, except that Econet had always been by design 100 ohm impedance cable system, and for some reason the cable recommended by Acorn and consequently recommended by SJ in our first few months was a 60 ohm cable, and that gave you poor performance on a large network. So we eventually specified our own cable, got it manufactured custom by a cable manufacturer, and we would sell it to people. The gorilla on the slide represents the lorry driver who delivered it to us, because it arrived on a big lorry with no tail lift, and this guy would lift the reels of cable off the back of his lorry onto the pavement of Mill Road without any assistance. We would then open the trapdoor, which we shared with the Curry Queen. They rolled their drums of mango chutney down it. We rolled our reels of Econet cable down it and turned the other way into our cellar rather than their cellar. So we sold that cable. We did have one customer, in fact, the same customer who wanted the opto-isolated bridge also wanted an armored cable. When that turned up, even the gorilla couldn't unload it off. He said, "Where's your forklift?" And we said, "We haven't got a forklift." So we hastily arranged for him to deliver it direct to the customer who wanted, who I hope had a forklift, as it weighed probably literally a ton. We found an awful lot of bad electrical installations. You would think that schools were careful with their electrical installations, but they were not. We found places with no earth. We found places with live and neutral swapped, all manner of problems. In particular, if you had no earth, that meant the earth on the BBC would float to 120 volts or so, which meant you got, when you connected those earths together with your Econet cables, you got 120 volts between different BBCs and you blew up the Econet interface. So we spent a fair bit of time debugging people who had that. We sold the transient suppressor to try and help people with Econet line driver blowing up problems, but which was a problem when people got lightning strikes nearby. Unfortunately, we didn't really understand what the problem was, and although the transient suppressor would have suppressed transients traveling in induced in the cable, that wasn't what the problem actually was. So I apologize to anyone who bought a transient suppressor. It wasn't the solution to the problem. In fact, if you installed it the way we recommended with an earth stake, it actually made the problem worse. The real problem there was that if you had multiple buildings and you got a lightning strike nearby, the potential of earth was different between the different buildings because you've got these thousands of amps of the lightning flowing through the earth and you've got a voltage gradient through the soil and different buildings float up and down. The right answer would have been lots more opto-isolation. So that customer who asked for the opto-isolated bridge, that was the right answer, and I wish we'd done that more widely, but we didn't. Ultimately, Econet was just good enough for the job. People with big sites had to keep a stock of spare line drivers and go and replace them when they got blown up, but they were in sockets and it was a 2-minute job to replace it, so it was just about good enough. There were plenty of people running large installations and they did all work once you'd fixed the problems, provided you had a supply of spare line drivers if there was a lightning strike. And yet again, Acorn came calling and we answered. The Acorn communicator was a strange machine. It had the 65SC816 16-bit switchable processor, which could be a 6502 or it could be a 16-bit machine under instruction control. It had the Electron ULA for video, but because it was being sold into markets where Prestel was important, it had a Mode 7 display through an I2C interface chip, chip that was made for use in televisions, and it had a modem. It was sold as a networked machine with a branded file store as its file server. This was a bit of a Cinderella project at Acorn, as at that time everyone competent was working on ARM stuff, and not much resource was being given to this thing, but there were orders for it and it needed to be delivered. So the call went out to contractors and Paul Bond was back again to do the operating system, and I got called in for a month or two to do the Econet on it, which was mainly a case of porting the Econet primitives from the BBC. I've forgotten what the operating system was more sophisticated than the BBC operating system, and it laid some of the basis for features of RISC-OS modules and things that I've forgotten the exact details. The big thing I remember is that that processor was an absolute pig to code for. You would write your code thinking very hard about width errors. You would finish writing it, you would sit down and you would comb through it looking for width errors. You would run it and it wouldn't work. And when you debugged it, the problem would be there was a width error in it. It was painful because the point was that the processor had two mode bits that made the XY registers and or the accumulator either 8-bit or 16-bit, and the instruction sizes of things like load A immediate change depending on that. So you needed the state of the processor when it was running and the state of the assembler when it was assembling to be the same, and it was just too hard to get that right, which we did in the end, but it was I don't recommend it. The other thing with that processor, I spent a lot of effort trying to make the Econet go faster, because being a 16-bit machine, it's got more registers, which means slower NMI latency and slower Econet. So I polished it as much as I could, but it was never as fast as most other machines on Econet. That brings us to the Acorn file store. I haven't been able to prove this, but I think it was developed for the communicator. There was certainly a communicator branded one, which was painted the purpley sort of color that the communicator is. I think that that came first and selling it to the general market came second, but I'm not completely sure. And maybe it was done with both in mind at the same time. Someone decided to fit it with a really stupid feature. You know, we decided back in 1981 that internal clocks were a bad idea. This was a doubly bad idea. It was an auto clock that would turn itself on when you weren't thinking about it, and it wasn't compatible with external terminators. So it was handy if you just wanted to run one file store with one communicator, but the rest of the time it would turn itself on when you weren't expecting and trash the rest of your network when you plugged it in. So it was a royal pain. Apart from that, it was mostly a packaging of the existing level 2, level 3 file server. It still only had 64K of RAM. It had 3.5-inch floppies, and it had a hard disk, the first version, with effectively a BBC 1 MHz bus going out to the second unit, and later it put SCSI in the main unit. We at SJ considered it a bit of a lackluster product. It was basically the level 2 or level 3 file server put in a nice box. And the box was quite nice. The idea of the front panel that automatically unmounted your disks when you opened the door was quite good, although in the real world most front panels ended up attached with blue tack because they weren't strong enough. So that was another competitor for us, but it wasn't really a very strong competitor. Non-education Econet use. I've already mentioned Reuters. I'm sure there was a lot of non-education Econet use. Like one of the other talks said, you only get to see the people who've got problems. You don't see the people where it's all going fine. But here's a few to play with. Portsmouth Greyhound track was an interesting one. The tote system for betting at the Greyhound track, there was a company that did this. So they'd gone in on Monday morning, they'd ripped out the old system, they'd started installing their Econet-based betting system. And we got over that week a series of increasingly anxious support calls from this guy. I think he wasn't using any SJ equipment apart from clocks and terminators, but we were the only people who would talk to him. And basically he had disabled the ability of this Greyhound track to make money to install his kit. And he expected it to be working on Tuesday, and it wasn't working, and it wasn't working, and it was coming up to the big race meeting on Friday, and oh my God, what's going to happen? So eventually he got desperate enough to pay whatever we decided to charge for me to go down there and sort it out for him. And the poor guy, he'd been working all this time, and I got there and I solved the problem in 15 minutes. Because what the problem was he'd bought he was using System 3s, and his System 3 Econet cards he'd bought from Control Universal, who were using the 1980 component values. They hadn't picked up the changes that we discovered with the needing to bend the resistors and all that lot. And so his System 3 cards collision detect didn't work properly, and that was stuffing up his whole network. So yeah, I spent 10 minutes checking all his work, which was the work he'd done was perfectly fine. Then I thought, well, what's going on in here? And I opened the front cover and I looked and said, hold on a minute, this is wrong. I was never quite sure whether Control Universal made those under license from Acorn or whether they were a knockoff copy, but anyway, that was that. AutoQ Limited, who made AutoQ, surprisingly enough, they used MDFSs and BBCs as data entry terminals, and then the text appeared in front of the people reading the news, driven by another BBC. So that was, yeah, making use of Econet. The GNOME at Home. So this was Glyn Phillips and Mel Pullen, who'd both been at Acorn back in '81. Well, Mel, who I'd taken over the teletext from, and Glyn was doing the PET and FIT test boards for the BBC Micro at that time. Anyway, they'd been doing a lot of Prestel related stuff. They had finally written that Prestel editing terminal that I was meant to be writing for Acorn. And they ran the GNOME at Home, which was a bulletin board you dialed up from your BBC to their system, which had a whole bunch of modems connected to BBCs and a SJ file server as the backbone of that. I say also Communitel. Communitel was another piece of software that did a similar job. It let you be a Prestel host on a BBC Micro. That itself wasn't an Econet product, but you could run it on one station on an Econet network and use that to export the information you created on your Econet. So Felstead used that, for example, to publish the various data off their network to be externally accessible. And indeed, they got their modem paid for by a local farmer who used it to access their weather data. That Felstead had a weather station that collected the rainfall and the wind speed and so on. And this farmer was able to use Felstead's data to prove that when his barn fell down, it was due to high wind, not because of his barn being decrepit. And so he was able to collect his insurance, and he was sufficiently grateful that he gave us a free modem. Redwood Publishing, publishing house who published Acorn User, they again used BBC Micros for all their data entry. Maritime Dynamics were somewhere in South Wales, I forget exactly where, but they built ship simulators. So think flying simulators, only much bigger and much slower. So you had a bunch of windows you could look out of, and you had the wheel and the engine equipment, and each of these things was a big physical stand with a BBC Micro in it initially, and later on with an Archimedes in it, and hooked all together with Econet to share the data between them. So, having pretty much sewed up Econet file servers, the next thing SJ did was not quite an Econet thing, although it was exploiting the use of Econet. There was a DTI Modems in Schools scheme, which was widely called the Modems in Schools Cupboard scheme, because the DTI had funded a modem for each school, but they hadn't funded anything for you to actually do with it. And one modem in front of a class, when you couldn't afford the telephone charges, and you couldn't let individual pupils use it, what were you going to use it for? So a lot of these modems are sitting around in schools doing nothing. And we thought, what can we use them for? Again, over a curry and the Curry Queen, we debated this. And we thought, well, suppose if we do local email on the Econet, and then we use the modem to transfer between schools in a batch fashion, that will keep the phone charges down. In fact, I recently read about a special tariff BT offered you for a high standing charge. You could then make as many calls as you like between midnight and 6 AM. So we did that, which provided email for as many people pupils as they wanted to register in a school to any other school on the system. The latest buzzword in the press was X400 for email. So we thought that sounded good, so we might as well implement that rather than inventing our own. Nobody told us that industry debate at the time was whether it could possibly fit in a 640k PC or whether it needed something bigger than that. Well, we implemented it on a BBC Micro and we only cheated slightly. And because of that, it could transfer binary files, it could transfer fax pages as image files. Optimizing the display software for that on the BBC was quite interesting. So some of our schools use that for software distribution as well as for educational email use. Ultimately, it was a technical success. It worked, people liked it, but it was a commercial failure. It basically required too much teacher effort to really make use of it. You had to register all the users, you had to get them using, you had to give them a reason to use it, which one of our LEA customers did that. They got a lot of use out of it. They really liked it. But not enough people did to give it critical mass to make it a commercial proposition. However, because we decided to build it on X400, we had built half of what was much in demand, a standards compliant OSI email system, which lots of people wanted to buy at that point. And a company called Nettel had done the other half. Nettel was John Horton, ex-Acorn, and a bunch of other guys from GC Computer, who, as mentioned earlier, was the people who did Prestel and the successor of our 803 computer. So that's by the by, but anyway, we obviously knew each other, and we discovered almost by chance that we had started at the highest levels and were working down the stack, and they had started with the low levels of the X25 and the communications bits and were working up. And we had almost exactly, if you put our two pieces of software together, you had got what was needed for standards compliant email on a PC. So we sold lots of that to UK government and the European Commission and people like that. And eventually Interspan merged with Nettel and we shut down the educational service. So at that point, I moved over to that side and spent the next 10 years of my life doing email. Although for much of it, I was still in the same office as SJ, and so I still had a finger in the Econet pie. Meantime, back on the Econet, the Archimedes came out, which was fine, no problem. Same Econet hardware as the master. A300, 400 generation came out, so schools weren't buying classroom sets of them. They were buying one or two, maybe, attach them to your existing Econet, no problem. Quite a few of them have got hard drive built in, or they've all got floppy built in, so it's not a big deal. However, over time, bigger fleets appeared, and particularly the A3000 being a cheaper machine, and we were now starting to see classroom sets of machines, and the Econet really couldn't cope with the size of application files on RISCOS. And another driver of this we were seeing installs in primary schools, which up to that point had been maybe a single BBC and so didn't need Econet, didn't need networking of any sort. Now they were buying a cluster of machines and they were A3000s and they potentially needed networking. So that was a problem. And just to fill in the timeline, around this time also the R140 appeared, which was Acorn's machine with BSD Unix on it. Wasn't really marketed at schools, but it did do IP over Econet. So that's a relevant point, and it provided an API for the Econet low level under BSD Unix. Ethernet at this time was not the answer to your problem. Ethernet was very expensive. 10-base-T hadn't been invented yet. So you had the choice of 10-base-2, which didn't go very far and was a bit flaky for use in the classroom, or you had 10^5, where still the AUIs were more expensive than the machines you wanted to connect to it. And the Acorn TCP/IP software was expensive, £200 a machine or £1,000 for a site license. So altogether, Ethernet was not something that schools could consider. So this was a bit of a problem. We decided to try something completely different. We took an 80386 PC, we put System 5 Unix on it, we took our existing PC Econet card, and BBCs could be terminals to this Unix machine using the existing Starfast. That worked very nicely, but nobody really wanted that at that time. Being a 386, it could also run MS-DOS or DR-DOS or whatever DOS was currently in flavor in a virtual machine. And you could do CGA graphics in your virtual machine over Econet onto a BBC, and it worked. Unfortunately, it was dog slow. This is before the open source Unix era, so it was all closed source, and we couldn't get the hook we needed from the virtual memory system to make it go fast. And it was too expensive because we were paying for the hardware, we were paying license fees for Unix. We did show it off at an exhibition, but we never really launched it because it was a fine technical exercise, but it didn't really work as a product. But we spent a fair bit of time trying that. It would have been nice if it worked. And we'll see later that it could have been nice if things had been different. So in 1990, we decided to go yet another different way. The thinking here was the Econet file server is already perfected for storing user data. User data hasn't got much bigger. The Econet file server is still fine for that. People have still got their BBCs. No one throws these things away. They can't afford complete rip and replace. So the Archimedes were extra on top of the BBCs rather than in place of them. So the only problem is the size of the Archimedes applications. So the solution is to provide a relatively cheap way of fixing that. And like the original concept for Econet, which took CSMA, CD networking ideas, but did it very cheaply with off-the-shelf chips, we took ATM, which was fashionable at that time, and built it out of off-the-shelf chips. The off-the-shelf chips in question being NMOS transputers. So that gave you a link that was 20 megabits per second bidirectional. It was intended for building inside a machine multiprocessor things linked together in a matrix, but simple RS-42 line drivers meant that you could go between machines, and then your transputer chip that was meant to be the node on this matrix had 4 links. So if you got one link and you put a 4-port thing behind it, that gives you 3 outputs for 1 input. So each chip you add adds 2 ports to what you had. So we built a unit that had 4 ports in the basic thing, and you could put in 2 extra modules to take it up to 8 ports. That connected up to 8 Archimedes to share a hard disk. This was relatively cheap compared to a file server. It was completely dumb. It just shared disk sectors, but it shared them very fast. And a bit later, the internal expansion became an external router box, and the software got more sophisticated. So instead of just the disk sharing, it was now a proper network again, and you could run emulated Econet over it. And by this time, SJ had taken over the Acorn bridges, and so the bridge from Econet to Nexus was invented, which was basically inside that box was an Acorn bridge with one of the Econets replaced by a transputer link chip, and so a link to the Nexus network. So that all worked quite nicely. There was a version called Nexus Junior, which just did the network with no sharer box for small systems that just wanted to share a hard drive directly on one of the Archimedes to the other machines. And that was a reasonable solution to the problem. However, various things came at this point to kill us. The worst thing really was local management of schools. As I said back earlier on, we primarily sold to LEAs, or at least we educated LEAs that Econet was a good thing, and they told all their schools to buy it. Local management of schools in 1990 meant that all the schools held their own budgets and they needed to be sold to individually, which was a lot more selling for us to do. And we didn't have the margin to do that. One approach to this bet was coming around again. We needed an exhibition stand. We'd frequently made exhibition stands that were multi-purpose, but this was the ultimate. We bought a second-hand bus from the local bus company. We painted it in SJ colors, and this time Bet was now in Olympia rather than the claustrophobic place in the Barbican. So we needed a big exhibition stand, and the bus was just fine. You could drive it in there, and it made an exhibition stand, and then after the exhibition we could drive it around the countryside, visiting individual schools and selling to them in the way that we hadn't needed to do previously. A slight snag that between measuring up and actually going there, they'd changed the doors, so we had to let the air out of the tyres to get it in, but it did fit into Olympia and it did come out. But that wasn't enough. It was becoming too hard to sell to schools. It was becoming harder than ever to make the argument we'd always had to make about education versus training, that schools should be teaching pupils about, for example, word processing as a concept. They shouldn't be training them in how to use WordStar, because by the time they get out into the workforce, that won't be current. But we had this argument over WordStar in the 80s, over MS Word DOS version in the early 90s, and Word for Windows later on. People said you have to teach the thing that people are going to use in the workspace, which meant that you couldn't use Acorn kit. As I say, there was a good argument why that wasn't the case, but you now had to make that argument to thousands of individual schools and individual boards of governors who weren't focused on thinking about this stuff. So that got harder. And also Econet was coming along. Econet would have killed us eventually in terms of the Nexus product, because it got so cheap. At this stage, Econet was still expensive and Nexus was still a cheaper solution, so it was still a good product. SJ tried to get around this. They transferred the Econet and Nexus products to Cumana, who sold disk drives and all the other range of hardware that schools wanted. So the idea there being that one Cumana salesman could visit and sell all this stuff, rather than an SJ salesman having to sell just one element of the system. That would have given more economy of scale, but that wasn't enough. Cumana themselves went broke. So the Nexus products that SJ had intended to hand over to Cumana, because Cumana didn't complete that deal, the products came back to SJ. SJ, meantime, were trying to pivot away from the education market into commercial ATM, and they were having some degree of success. Just like we did with Interspan, they expanded from Nexus built on ATM principles to standards-based ATM. They were involved in the Cambridge Interactive TV trial with Acorn Online Media. They built the squid boxes and the roadside cabinets. They built ATM interfaces to go in the Acorn set-top boxes. It was a strange box to go on the outside of American houses built for Ericsson. They were starting to develop a big ATM switch. But unfortunately, it was ultimately too late. The Econet Nexus income was dwindling. and that wasn't enough to finance a pivot to this other market. It needed venture finance, and they very nearly raised the venture finance to do that, but they couldn't do it. So in 1996, unfortunately, SJ Research came to an end. As I say, the products had come back from Cumana, but they were sold off to a consortium of dealers and ex-SJ people too, so that at least people had support and for their Nexus installations. And finally, a Phoenix company, SJ Consulting, took up the ATM stuff and the set-top box stuff and spent another 10 years doing set-top boxes. Ultimately, that company was sold to Amino Technologies in a deal brokered by Paul Fellows, who was ex-Acorn and been subject of another of these talks. So that was another connection of the Acorn world. In particular, that was the end of the Acorn-Sinclair divide. I've talked about lots of these companies that were set up by ex-Acorn people, but all through the 80s, there was a divide between Acorn people setting up their companies who all worked for each other in a rather incestuous way. And there were the Sinclair people who did likewise. But by the time it got to well, turn of the century, Amino had Jim Westwood from Sinclair and Paul Fellows from Acorn, and the two worlds were mixed. So that was the end of an era. So that was the end of SJ, but Econet lived on for quite a while. In particular, Econet really lived on so long that there's a big overlap between real live production Econet use and the modern era of preservation retro computing Econet use. I think there were people doing retro computing Econet before the last production Econets had got turned off. Back at Felsted School, there was, by this time, they were running a mixture of Ethernet, Econet, and a little bit of Nexus. They got BBCs and Archimedes. Staff and pupil personal machines were starting to appear. This was probably similar in other schools, the bring your own devices issue. They bought a bunch of Acorn NC machines as a cheap way of doing RISC-OS in the late 90s because there was a big budget crunch around that time. This was the start of the internet age and open source stuff was coming around. So in 1996, I helped them out with a FreeBSD machine, which was the ultimate file server. It had an SJ Econet card in it, so it could talk real Econet to BBCs. It could talk AUN over Ethernet to all the RISC-OS machines. It could talk to the staff-owned Macs and PCs and stuff using open source stuff. So to enable that, I wrote a FreeBSD driver for the SJ PC Econet card using the driver API specified by the R140. I found a file server kicking around ex-Acorn written by Brian Knight, and judging from the comments, it was converted from Modular 2, so it must have originated in the American, the thing that should have been RISC-OS but wasn't project. Anyway, I acquired a copy of that under the counter and I extended it to use the Unix permissions and the same the same file access controls and to do AUN as well as real Econet. I wish now I'd written it from scratch rather than getting this thing under the counter, because then I could have given it out to more people. But anyway, that's the way it went. We did proxying over TCP for remote Econet islands. Although all the Econet machines were connected together, you might have to trip over 5 bridges to get to the main file server over Econet. But once Ethernet had penetrated a bit further, you could go a couple of hops on Econet and then hop over to Ethernet via this proxy thing, and we broadcast some of the we'll broadcast the weather data over Ethernet in AUN format and so on. I wrote a thing called BBC Term, which allowed your Starfast terminals to become terminals to the BSD machine. So this was the SJ application server, only this time that was something people actually wanted, because now you could use your BBC as an email terminal, and you could even browse the web using the Lynx text web browser, which wouldn't be useful today, but was useful in those days. And with Acorn grinding to a halt, diskless X terminals was something that Felsted were doing as a way of getting cheap terminals to expand their network. Obviously, I wasn't doing Econet professionally anymore, so I wasn't in contact with everybody, but there were lots more people doing Econet right into the late 90s and later. Another one who I was in contact with was Hennick Hall College. This is a residential school for pupils with various kinds of disability. So they were a big Econet user. In the beginning, they used Econet and BBCs for everything: admin, educational software, recreational use of games. As I say, they had a wide variety of pupils. So they had some pupils who were very bright and were challenging me on the SJ secure logon stuff. And on the other hand, they had pupils with learning disability. You know, they found they had to keep emptying 2p coins out of the speaker grills on their BBCs, because this guy decided that the BBCs were like a arcade game, and so you ought to feed 2p's in to keep them happy. They had MDFS and Nexus and Ethernet, and I slipped them one of my Econet cards and my EcoFS. They carried on using Econet. They switched off in 2007. So I asked them why they kept on using it so late. The sort of applications keeping it going were the teletext server and the games. But I think a lot of people, Felsted and Hinnick and lots of other places, they'd still got BBCs. BBCs still worked. A BBC on an Econet was an appliance that just worked, that didn't need maintenance, that didn't give trouble. Your control brake, shift brake, very fast access. If you wanted to check your email in a 30-minute break, did you want to find a PC and get logged into it and get it booted up, or did you want to go to a BBC where, yeah, control brake, shift brake, 2 keystrokes, you're in and out and done in 30 seconds. So Econet really lived on. Finally, Felsted the wind down of Econet there. Peak Econet was in 1998. 22 networks with 21 bridges covering 25 buildings spread over 50 acres. Maybe 200 machines on Econet at that point, bearing in mind that by this time they had Ethernet as well. As we wound down the Econet, we started running Ethernet over Econet cables, because that SJ cable with its 100 ohm impedance was just the right spec to run Econet, that run Ethernet 10 base T over. So those cables, some of them are still in use today. And as I just said, the BBCs were still useful right up to the end, because they were convenient machines. They were effectively free. They were paid for years ago, and they were useful. Yeah, the notice board and the teletext, again, were anchor applications that kept the BBCs alive. Unfortunately, there was a change of management there in 2003, and they started switching from Acorn to Windows, and Econet was, there wasn't a hard switch off date, but it was effectively out of use after 2005. So thank you for listening if you're still there. That was, yeah, my story of 25 years of Econet. Thank you.
Great, thank you, Andrew. So we've got a couple of questions that have come in, of course, and what we'll do, we've got a bit of time, so we'll open it up as well for questions from the floor afterwards. Just to go through these ones. Phil M, like SJ Research at Clear Techniques, they develop products for both Econet and Cambridge Ring. But around 85, 86, started using a product called InfraPlug, which carried serial traffic around a ring of 75 ohm coax between the plugs. Did SJ Research ever use this product or market it?
We certainly never used it. That might be the other product. Back on one of my slides, I said DSL and something else that I can't remember. That might have been the one I can't remember, but I still can't remember it now. So,
well, got a couple of comments on that. That might have been Amcom Enet that you were thinking of.
Ah, that rings a bell. Yes.
With a comment from Jonathan of spit guru ganash guru after the Amcom Enet. Not a very good system. He also mentioned that some other commercial uses were in Hong Kong, their harbour planning control, and at the Hong Kong Stock Exchange, no less, which I think Reuters were also involved in and ties in with the SJ cards as well, I think. DSL, Phil P, I think you did mention it, Digital Systems Limited. Is that correct?
Digital Services.
Services.
I think. Yeah. Well, DSL was what we called them, but I think it was Digital Services, and Digital Services were the people who did Squirrel, and I think it was the same people. But
yeah, Services then, and Phil's just confirming that as well. Then, Richard. Sorry, no, Phil again. Did Felsted School archive any of their items? Do you know? Because they have such a wide range of software there for the Econet.
They've certainly got some stuff. I've been talking to Chris Dawkins while preparing this talk. He's got a lot of stuff in his shed, like my attic. How much of it will work when it comes out, I'm not sure. Ironically, he, having left his job as running the computers there, he's taken the job of archivist for the school, so he's not only maintaining the computer archive, but there's also other archive stuff. So he has intention to get that stuff sorted out, but exactly when that will happen, if ever, I don't know.
Sounds as if we need an emulation for the SJ Research various servers that we could then run things from.
Possibly.
That may be a way to do it virtually as well, to a virtual Felsted School archive.
Yes, so you could get most of it by running my EcoFS on a PC. Yeah, I've seen people recently talking about running BBEM with AUN on the back end, so that into one of my file servers would give you a emulated network. It's all not quite right, but a bit of tweaking could make that go.
BBEM does work with AUN at the moment, and level 3 can be run. So, but what we would need is the file server emulation.
Yeah, we want the disk that was in the file server. We don't necessarily need the file server to run it, but we need all the files that were on it.
Was that format for your drives? Well, there's another question. Were the SCSE drives all Rodimes in MDFS, or were they various SCSE?
They were a wide variety of things. One of the things that caused us that financial issue over margin on selling drives was that around that time, all the hard drive manufacturers had a disaster over stiction. That all their, everyone suffered it one after the other, not all at the same time. So you'd pick one drive that seemed to be good, and then you'd find later that it wasn't, because it was the technology that everyone was using that wasn't not worked out at that time. So, which was a big issue for us, because we would get a 12-month warranty from the drive manufacturer. We would keep the drives in stock for a month or two and sell them to the customer. And after about 12 months of actual use, they would fail. So that invariably meant us picking up the repair for the customer and not getting the reimbursement from Rhode. I remember a big pile of Rhode arms that came back from Rhode Island that said reworks on a big label on the front, and someone had written FI, so it wrote fireworks because we didn't trust them.
So you used a variety of manufacturers.
Rodime, and then Connor, and then Fujitsu were the main ones we used in the MDFS era.
The MDFS file format, that was proprietary though as well, wasn't it? Or was it the same as the Acorn file server?
No, it was completely different to Acorn's. Yeah. Though I've seen people outside documenting it, and well, I could tell you what it was if you couldn't already find. We may even have documented it in the SJ manual. I can't remember. I've seen it recently online somewhere and thought, yes, you've got that about right. Yeah. So that
absolutely. So Jonathan's been mentioning a soft MDFS and MDFS emulation is on his list. So there's definitely interest there to do something in that.
I was thinking this morning we could probably run one of the early file servers on an emulated Z82 processor. I don't think we ever did that back in the day, but the file server that ran on the FDFS, that ran on early HDFS, that ran on the NASCOM at Felsted, that file server was portable and with a small amount of work would have run on a Z82 processor. I don't think we ever did it, but it would be easy to do. So that would be another route for an emulated file server on emulations that already exist.
I think that's where some interest does lie at the moment in people. And finally on this, Richard Tricky says, he actually echoes the sentiments of many, many people. I think he said, thank you very much. I had no idea how wide-reaching Econet and its associated technologies were.
Well, it was an interesting 25 years, certainly.
So that's the questions that we've got from the Zoom chat, etc., and from the Discord server. So if you can raise your hand first, and then we can make sure that your video's on, etc., and then we can pick who to go, so we don't get people talking over each other, etc. And Trevor also says, whilst we're just waiting for people to raise their hands, an interesting talk, fascinating to see the start of Econet being a solution to schools loading tapes to multiple computers through to Archimedes sharing the same hard disk. So following the whole lifespan of the evolution of the Acorn and microcomputers in the schools. And Phil Pem also, that was a fascinating and really interesting talk. Thanks, Andrew. So you can see, everybody, why we extended this talk and allocated it the time that we did. We did feel it was quite necessary because Andrew has just got so many interesting things to tell us about.
Well, I've had great fun over the last couple of weeks mining my filing cabinets and talking to people who really can't remember what happened back then.
So is there anybody then on the video that would like to ask a question? We've got anybody there? As usual, it's the deathly silence. So everyone's still astounded by the talk and taking in the volumes of information that you've been able to give us, Andrew, because there was an awful lot of information for people to digest there. Absolutely fascinating as well to hear, not just about the early days, but the more recent days, and that it was still running in the 2000s even.
I've got a mark, and Andrew, if you're still up for questions.
Please, go ahead, Dominic.
The 100 ohm, 60 ohm cock-up on the cabling, was that 100 ohms sort of a design decision that was forced by the hardware chips, or was it just miscommunication?
Well, the the hardware had always been designed for 100 ohm. The terminators were always 100 ohm termination. And as I don't know where that came from. It may be that someone thought that the resistance of the cable was what mattered, because this new cable that got specified was quite thick. It had much lower end-to-end resistance. So I imagine someone was thinking collision detect's not working. That's because the resistance of the cable is too high, and what's effectively a short circuit down the other end is invisible to this end. And so they picked that cable without looking properly at the specification and realizing it was the wrong characteristic impedance. I imagine that that's what happened, but it was rather unfortunate because it really didn't perform well. Although the line drivers could just about drive into a, remember they were driving both directions, so they would be seeing 50 ohms in a proper system or 30 ohms with this wrong cable. But the thing that killed you was you then had a drop lead from the computer to the socket box, and the resistance of that meant you got a lot of attenuation between the computer and the socket box on the 60 ohm cable, and the signal levels were just not adequate.
And do you know why they picked DIN cables, DIN plugs rather?
I have heard it said, but I don't know, that they were University Audio was across the street and they were easy to
found something to skip.
I don't know whether that's accurate. A lot of things did use DIN plugs. Of course, the whole back of the BBC Micro is DIN plugs. The System 3, quite a lot of things had things on DIN plugs. The video was on a DIN plug. The what was the versatile interface adapter called that had DIN plugs for its serial port. So DIN plugs were in use in Acorn. Whether that story is right as to why they were in use, or just because they were a cheap multi-pole connector, could have
I
been.
just wondered if it was because people are already sending audio over them in classrooms and they just thought, oh no,
that happened the other way round.
The other way around, yeah.
People bought Econet cables and then found without any Econet interfaces they could temporarily use them for cassettes.
Yeah.
Given that some people may have been inspired now to actually have a go at Econet themselves, what advice would you give to anyone building their own little network at home, etc., or trying to connect a few machines? Given some of the experiences you've had, what things would you say to watch out for? What would you tell them to do?
If you're just building a tabletop network, you can get away with a lot of things being not right. You can use any old cable. Do make sure that your machines with switch mode power supplies are properly earthed. Dodgy four-way mains adapters will destroy your Econet interfaces. So don't do that. Obviously you want an SJ clock and no other clock is acceptable, but actually anything will do. If you're mixing and matching things, if you're desperate, you can fit the clock and terminator on a issue 3 BBC-B circuit board and it will work, but that clock will not drive one of the Acorn or SJ passive terminators. So you could build a tabletop network with a BBC-B, fit the components for clock and terminator on the BBC-B and do nothing else. Don't terminate the other end of the network. There's a short, a 10-meter network will be happy with only one terminator. Whereas if you try and put one of the passive terminators that's expecting to get power from the clock and the BBC isn't giving it you, that's not going to work.
So, and especially if you're using multiple machines, you've got one BBC, one master, one Archimedes, let's say, go for an external clock and get it done properly.
That would be the preference. And your clock speed is going to depend on what machines you've got. Archimedes will go faster than BBCs. If you use bridges, get a recent version of the bridge code. I'm not sure how I can help you with that. I've got a source code listing of the version of the bridge after the speed improvements were done. Not sure if I've actually got it on machine readable media, but I expect somebody's got that out there because the bridges were not that rare. But later bridges will go faster. So
that's the SJ bridge. Yes.
Either the SJ bridge or a later ROM in the Acorn bridge, or either will.
So that collision detection can be fixed with just by the ROM. It's not a hardware issue.
The collision detection will be never fixed, but you live with that. Yeah. Okay. People live with that for 10 years. It means broadcasts are less reliable, but again, in a tabletop network, that's not going to be a big deal for you. So your ideal setup, though, would be a bridge with your Archimedes on one side going very fast and your BBC on the other side. SJ file servers were somewhere in the middle. Again, you want more recent software because Stephen did more work on that. Yeah. In the beginning, we made them go faster than BBCs, and that was fast enough. Later on, Archimedes were faster, and we polished our code to try and catch up.
Okay, so we do have some of those bridge ROMs archived as well. So Nigel's got some copies of those. So if anyone is picking them up off eBay or does need a newer version, that we definitely got some around that we can help with as well if people are running into issues there. Brilliant. And I'm sure some people are going to be inspired to have a go and try and connect up a few different variants between the Atoms, BBCs, all the way up to the Archimedes and RISC PC ranges, and maybe bridging it to something else as well. So that's about it then. It just remains for us to give Andrew our appreciation, to say thank you for all of his time and the great amount of hard work and effort he's actually put into preparing this talk. He's done a lot of research for it, talking with people, getting things out of his attic, having a good read, scratch of his head, having another read again, going back and checking it with somebody, and then going through the slides multiple times. I know he's been through many revisions, and there's been a great amount of effort. It is very much appreciated. Andrew, thank you very much.
Thank you. And if people do have last-minute questions, I am around on the forum at the moment, so I will answer questions offline.
Thank you very much, Andrew, and it's been greatly appreciated. Thank you.